Hello, hello. Welcome, everyone. Thank you for coming to Encryption Day. We're going to start off with two panels right now. First of all, thank you to our sponsors for making the event possible. We have Optalysis, Highly, Silhouette, Horizon, and Artifact Systems. Here's a brief overview of the schedule. So we'll have two panels going on, and we'll do a lunch intermission at 12:45. More people are going to tune in as there's some workshop sessions going in the other room right now. They're all wrapping up. They're all going to head over. We'll have two panels right now, and then we'll head back for lunch, and we'll let you know when that's over. So thank you all for coming. So first up, we have like a FHE IRL panel featuring like FHE designs in real life applications. So that's going to feature Alpha Engine, Phoenix, Exosphere, and Secret Network. So thank you all for coming, and yeah, welcome.
Hello everyone. Morning. Afternoon. Oh, good afternoon everyone. So welcome to today's panel section. So we'll be on FHE. FHE in real life. I believe everyone can hear me. Can everyone hear me? Awesome. So tell us about yourself, what you do, and why you're here. So let's start with Ilya.
Hi, I'm Nilay, the founder of Alpha Engine. We are building the confidential layer for Uniswap. We are using to encrypt all your swaps on Uniswap, and at the same time, we are solving the problem that people get on Uniswap by taking advantage of the idle liquidity that is there, and we allow it to be deployed to various DeFi protocols, thus ensuring that LPs earn higher yields. And all of this happens end-to-end encrypted, ensuring that your alpha is preserved and the best strategies are deployed on-chain.
Jeremy.
Hi, I'm Jeremy, founder CEO of Exosphere. We are providing confidentiality solutions for on-chain asset issuance.
So,
hey, I'm Tom. I'm the head of engineering for Phoenix. What we're doing is we're building a platform for developers to use FHE in smart contracts. So we're basically we support EVM compatible chain. We plug basically into any EVM compatible chain, and we provide encrypted variables, encrypted types, encrypted state for developers to use in their applications.
okay, Poblag, I lead business development effort at Secret Network Foundation. So Secret Network is a confidential layer for Web3, blockchain, AI, and applications. We provide confidential computing for Web3. So let's dive into today's section. Here's the question, first question. What made FHE finally practical? FHE has been in research for years, and implementation was often dismissed as too slow or impractical. We've heard that a lot. Until recently, everything has changed, and projects like yours are bringing FHE to the reward. So tell us, what does it feel like bringing FHE to the reward, to DeFi, to your applications you're building?
So, given the recent advancements in FHE, especially Phoenix's co-processor processing up to 64,000 encryptions and decryptions per second. So with that, we have been able to leverage it to encrypt and decrypt the swap intents and the complicated trading strategies, which would not have been possible earlier. Like right now, we are live on 3 testnets, and we see that even if we do some really complicated DeFi strategies like leverage looping, which involve multiple steps of encryptions and decryption, it all happens within a few seconds, and it almost feels like whatever trade we want to deploy, it's completely confidential and happening in real life. So with this recent progress of like the increase in computation speed, what we believe right now is that in future we'll have a lot more projects using confidentiality, even those who need like real-time computation, they should be able to use it pretty soon.
Cool, awesome. So, tell me, Tom, so, what is it like to build with encrypted data? Building applications where no one, not even the validators or Oracle, can see the data, which is, really, really awesome. Imagine being able to query encrypted data without actually revealing the details of the data. So, also, what has been the hardest part when it comes to building with encryption so far?
Yeah, so I mean, FHE is becoming to be a very powerful tool to build encrypted applications. The well, FHE has multiple strong suits. I guess one of them is that, as you mentioned, it fits very well with like the blockchain and like like public execution narrative and this like movement, because you can essentially keep encrypted data, you can compute over encrypted data in the public without revealing any information, or like very little information at least. So it's a very good fit for public spaces and like public VMs, public execution environments, like blockchains are. And a little bit about like what you mentioned regarding the performance earlier. I guess it's essentially like an outdated stigma by now. I see it as, FHE has been in research for a long time now. And in the recent years, there's been like incredible progress, both in the algorithmic side, like making FHE much more efficient and much faster, and also big advancement in the hardware side of things, and making it much more efficient, much more acceleratable. So we're looking right now and at like, tens, hundreds, thousands of transactions a second, which is essentially like you can claim it's slow at this point. And we're looking at even like, thousands, 10,000s of transactions a second, maybe a couple of years from now. And it's essentially getting very fast, getting to exactly where we need it to be to support like high throughput applications and high throughput use cases. We at Phoenix already solved the decryption part. So the decryption part is kind of a big blocker in the space because it's at least half of the problem, right? Because you need to do the encrypted computation, but everything that is encrypted eventually will need to be decrypted. Users want to see their balances, their like their activity on chain. Of course, you need to kind of protect who gets access to the data and so on. But the acceleration in the decryption part as well is something very, very important. And we've been working very hard at Phoenix on that as well. We released a paper recently. We got to like tens of thousands of decryptions a second. So yeah, it becomes very, very real, very usable, and it's a very important part in blockchain space.
Okay, being able to compute over encrypted data, it's very, very important, and without revealing the details of the data. But despite the trend, the narrative towards privacy, government has been showing interest towards privacy. So, how do we actually balance confidentiality and compliance, which is really important, since regulatory body would want to have access to some certain information, and being able to do so without actually revealing all your information to everyone, but just for compliance purposes. Confidential DeFi sounds really powerful, but also challenging from a compliance and transparency standpoint. So, how are we tackling the need to prove legitimacy, solvency, and risks without exposing sensitive data? And does FHE make the process easier, harder, or simply different? So, what do you think about that, Jeremy?
Yeah, first of all, like I would define confidentiality as a point on the spectrum of privacy, where on one extreme you have full anonymity, which is like maximum privacy. On the other extreme, you have full transparency. Confidentiality is somewhere in between those two. And it's really suitable for cases where the goal is not to completely obfuscate what's going on. and that's particularly useful for the enterprise and institutional space. And in the enterprise and institutional space, the number one concern tends to be compliance. So it's key for confidentiality solutions to be as easily compatible with companies' compliance processes. And I think that's one of the beauties of FHE. I think FHE facilitates this and makes it easy for builders that are creating solutions, confidentiality solutions for the enterprise, for the institutional space, to be able to provide those institutions with the ability to, using viewing keys, for example, to decrypt encrypted information when there's like a compliance or regulatory request or law enforcement request, for their compliance department to not need to go through a lot of friction or behavioral change in order to adopt these kinds of solutions. Like, we're at a very interesting moment today when I think that crypto is on the precipice of making huge gains in terms of acquiring more of the transaction flows of the enterprise and institutional world, and eventually becoming, making its way towards becoming default rails for money flows globally in the corporate world. So yeah, I would say that FHE is very well designed to facilitate that and to make that as painless as possible.
Agreed. There should be a bridge between transparency and privacy or confidentiality. And the user should be able to determine for how long and with whom they actually want to share their data with, which is very, very important. Nobody should have my data forever. There should be like a time zone, a limit to when they have access to the data and how they have access to the data, which is really, really cool. And traditionally, Web2 Web2 encryption is not like public. You just know that encryption happens in Web2, like whenever you send, receive funds, whenever you visit the healthcare and so on. But in Web3, do you think everyone should have access to encrypted file, or what does private or encrypted actually means in Web3? As we design the new era of encrypted systems, should privacy and encryption remain invisible to everyone, or should users be aware and they should be in control?
Yeah, so the way we try to tackle it in Phoenix is essentially, well, we all started in Web 2, right? Web 3, we got into eventually. And we all used to basically seamless experience. We kind of used to expect some level of privacy from the get-go. Like, you don't feel it, you just know it's there. You know that when you are using a messaging app, no one else can see it. We now are a bit more educated, and we know that we want it to be more sovereign, more decentralized. We want the control and want it to be decentralized. But still, like the day-to-day user, like the normies, expecting the privacy from the get-go. I think there is still a path to there. I think we're not quite there yet. I think it will take some time for privacy to be, transparent in a way, like, or invisible, as you said, like just for users to not feel this friction. Today, when you use private protocols and private applications, there's a little bit of friction. Like, it's not like your regular, application. Same goes for honestly, all Web3 applications. We try to make it as seamless as possible and as intuitive as possible for end users and developers as well. Like, I think a big part of creating great applications is for the developers to have a great experience building them as well. It needs to be easy for developers to integrate privacy into their applications, at least as much as it's easy for the users to use these features. So we try to playing on both sides of this field. Still, I think there's some way to go and ways to improve, but I believe we'll get there eventually.
Okay, so talking about scalability, cross-chain, and so on. At the moment, most privacy ecosystem or applications are kind of centered in a particular place, and or a single chain. So, but DeFi is rapidly growing. You could see DeFi on several public blockchain, but there's no sort of privacy in it. So, with messaging layers, aggregator, assets moving between space and so on, how does privacy and FHE in particular fit into this shift? Can confidentiality remain consistent as data moves across ecosystem, or it has to be centered on a particular chain? Or do you think there's a feature for cross-chain privacy?
So I believe there is definitely a future for cross-chain privacy because once you encrypt a data and you generate a proof that the encryption has been done correctly, then it stays consistent throughout, regardless of what chain you are processing it on. And then, which means that let's say if you encrypt some data on a given chain and then you utilize some messaging layers like maybe across or chain link CCIP, and then you just pass that data along with the proof. As long as the co-processors, like Phoenix is already live on three test nets. So as long as the co-processors are holding the same key, they can decrypt it on the given chain. And this is what we are also utilizing at Alpha Engine. So we are already working towards enabling cross-chain confidential swaps that you can come to Uniswap protocol. Uh, if you want to swap USDC for USDT on a different chain, you submit the intent. We take that encrypted intent and pass it to your target chain via messaging networks. And what I feel is that as of now itself, there is scope for cross-chain confidentiality. And this will also enable a lot more composability across DeFi because as we all know, the liquidity fragmentation problem, it gets like hugely solved if you can access multiple chains and their liquidities. So for sure, this is something which would be solved like pretty soon in the mainnet itself.
So at Secret, we also provide some sort of cross-chain confidentiality, which allows any applications or any chain to actually play around with encrypted storage payload, and also like seal deduction, private voting, which is not limited to a particular chain, but available to all users across Web3. And we all here believe this is privacy season. Do you think this is privacy season? Anyone? Okay, if we all agree this is privacy season, so what do you think is driving this renewed excitement in privacy? Because everyone is, saying it's privacy season, it's privacy, it's privacy. Do you think it's about the price, or people are actually, curious about privacy, interested in privacy, or truly value, confidentiality over their interaction, transaction on chain, or do you think it's just fueled by something else? Let me know what you think.
I'll go quickly. I'll go quickly. There are three reasons. Number one, I think in crypto, price usually leads narrative. Price goes up, and then the market tries to come up with a reason why it went up, and that creates a narrative. So I think like assets like Zcash, Railgun have really outperformed recently, and it has led to this strong narrative. I think number two, the tech has reached a level of maturity where it's actually tangibly there for privacy season to actually happen in terms of real applications and real usage. And number three is the trend towards enterprise and institutional adoption, which I think requires privacy as a core element, which makes privacy season, that brings that to light.
Agreed, agreed.
Thank you. That's all the time we have. Sorry.
All right, thank you very much. All right, so in just 30 seconds, can you tell me what I'm most excited about for FHE in the next year? In just 30 seconds, each of you, 30 seconds each.
I'm excited for crypto to penetrate into the enterprise market and to win that whole area of commerce, which is bigger than everything we have on chain today.
Nai.
So I'm excited about individual privacy, like users being able to protect their assets and like not getting doxxed on chain, and they access the entire blockchain while preserving their identity.
Okay, Tom.
FHE everywhere.
All right, thank you so much. Thank you so much for listening.
Thank you, everyone on the panel. Next up, we'll have a fireside chat between the co-founders of Off-Chain Labs and Phoenix. So thank you, everyone.
I have a question, which I may use, good. I may use or I may deviate from. Okay, we have a very, very special guest here and a very dear friend, Stephen Goldfeder, one of the true OGs in crypto and cryptography. So thank you for coming here.
Thank you for having me.
Amazing. So let's get right into it. So for those who don't know, Stephen is the co-founder of Arbitrum, tiny ecosystem that we are a part of. You know, you have this very cool slogan called Arbitrum Everywhere, and that's become your core messaging. And I'm kind of curious, what does that mean in practice, and how does that fit into privacy? Because this is a privacy and encryption event, so you got to plug that in.
Absolutely. So what Arbitrum Everywhere means to me, and before I start, I'll say you'll excuse me because it's beautiful here in Argentina, but unfortunately it's also allergy season. So if I've jumped back into spring, so if I'm sniffling or sneezing, please excuse me. But anyway, to answer your question, Arbitrum Everywhere to me means that really no matter who you are or what you're doing, if you're building in crypto, Arbitrum has a solution for you. And I'll tell you what that means. It means, you know, our competitors at the chain level, often they fall into two buckets. You'll get into a room with them and say, hey, should I build my own chain? Half of them will say yes, and half of them will say no, no, no. But if you ask us that question, we'll say maybe, because we have products that really go across the gamut. We have Arbitrum One, which is a top blockchain. We have Arbitrum Orbit, which is the most adopted stack for launching your own blockchain. And actually, even for people that aren't in the Arbitrum ecosystem, and I'll give you two examples, Arbitrum can help you. Hyperliquid is not an Arbitrum chain or an Arbitrum One, yet they source their USDC liquidity from Arbitrum, and Arbitrum plays a very big role in that product. And the idea is that even actually in competing ecosystems, like on Base, Base's top performing layer 3 blockchains, so Degen chain or Blackbird, if you're familiar, these are actually both Arbitrum chains that are paying 10% of their revenues back to the Arbitrum DAO. And that's broadly what we mean by Arbitrum Everywhere. But to connect it to the topic of the day, of course, the idea is that I don't come to say institutions and dictate and say, hey, this is what you need to do. This is what you should build, because every single institution is going to have its own corporate history, its own regulatory environment, and going to have its own requirements. What I say is, you tell me what you need to do on the blockchain, you tell me what your business objectives are, and we'll be able to provide the technology that actually supports that and allows you to meet that. And a core, actually, one of the most requested features today is this notion of privacy, of course, because as institutions come on chain, their users expect there to be the same privacy guarantees that they have in the real world, if you will, right? So what does that mean? It means it's often a slightly different model of privacy than we've had until now. Until now, we've kind of had the private blockchain model, which is basically chains are private, chains are public, but if it's public, and there's a set of people who know, a set of people who don't, and those who know everything. We've had like the Zcash model where everything is private from everyone. But the institutional privacy model is kind of like, I'm cool with the institution knowing my stuff, no problem. Like, they know where I live, they know how much money I have, yeah, they can totally ruin me. But I don't want my neighbor using the bank to be able to, snoop on what I'm doing or know anything about my transactions. And when it comes to a Phoenix specifically, I think one of the beauties of the way we work together is we have this core architecture, this core ecosystem. And it's amenable to actually be extended and to use some of the most advanced cryptography in the world and add that to the stack. And that's what we mean by Arbitrum Everywhere. We have this core stack, which we don't believe that everyone should be running the same thing, but you can customize it and to see some of the biggest experts in the world, Guy, Chris on their team, actually going ahead and building cryptography on chain to build next level and next generation privacy into the Arbitrum stack. That's couldn't be a better example of what we mean by Arbitrum everywhere, and that's really going to help serve the mass influx of privacy interest that we have today.
That's fantastic. I actually have a follow-up on that. Like, I think last week you tweeted that the original Arbitrum paper also had, like, on the title, you know, scalable and private smart contract, like something along those lines. I actually forgot about that. And I read the original paper in like 2018. I can't remember when that was.
I remember we talked about it.
Yeah. So, what changed? How did that evolve? How did your thinking around privacy evolve? And obviously, I mean, you can be a bit spicy and say, look, like maybe you changed your mind back then where privacy was not important because that's why you dropped it. But I'm kind of curious how your thinking evolved over time, you and Arbitrum more generally.
So I'll share some also additional old lore that I actually have never been shared publicly before, which is, so it's true, the initial Arbitrum paper had a notion of privacy. That notion of privacy kind of, it was meeting its time. At the time that paper was published in 2018, there were private blockchains and public blockchains, and private blockchains were these consortium chains, and banks, for example, had these chains, and there was a set of people that knew everything and a set of people that knew nothing. And the problem was they wanted this privacy in this way that it was more shielded from the public, but not from each other. But there was no security because they were just running these internal databases. And what we said is, hey, you could take the Arbitrum stack, actually have a private blockchain that's secured by a public blockchain. So that was the particular notion of privacy in that paper. But we were actually very, very interested in even a broader sense of privacy. So I actually looked back at this the other day because I was going to tweet it, but I didn't get around to. In 2017, Harry and I were hacking on a GitHub repo called Zarbitrum. This was a fork of Zcash, actually, and we added Arbitrum support to Zcash. It was a work in progress. We continued that for 2 years into 2019, and again, I literally looked back at this the other day. In 2019, I messaged Zuko, who was the founder of Zcash. I said, all right, I think we could build smart contract support into Zcash. We have this design. We had a whole spec we wrote out. Ultimately, things didn't go in that direction, but we've been very interested in privacy over time. But to answer your question, though, like, so what happened? I think, to be honest, the world wasn't ready. There's a graveyard of privacy solutions that launched just ahead of their time. And timing...
We know.
Yes, but you guys are fortunate that I mean, at least in this iteration, I know you've obviously been doing privacy at BC for a long time, but Phoenix is actually here at the right time when the institutions are here. But if you were 2 or 3 years earlier, as many people were, even if you had the absolute best technology, the fact is people didn't want it. People weren't ready yet. Institutions weren't here, and your average user didn't care about privacy. So timing is really everything in crypto. We were fortunate this with Arbitrum that we were ready to provide a scaling solution exactly, not a year before, not a year after when the ecosystem needed it. Privacy's moment is now. The graveyard is full of teams that were too early. And I think you guys have a very similar lucky fate that you're here at the right time when you can see privacy is just exploding.
Why do you think that is? Like, what is changing now? And you've seen all the iterations as have I. I've been asking myself that question almost on a daily basis. I'm curious, what's your take?
I think it's the normies are here. That's the real answer. And what that means is institutions are coming, but institutions are coming in a way that they want to bring on their institutional customers. And those may be retail customers, those may be businesses. And if you go to a business today and say, hey, we're going to build a neobank on chain. Fantastic. By the way, small detail is all of your activity is going to be public, right? Like, that's like terrible. I don't know if how many of us have Venmo, but like, I use Venmo, but the first thing I did when I opened my Venmo account was turned off the social feed because I don't want other people even seeing metadata about my transactions. I think that's the most bizarre feature that a payment app has ever launched. And the thing is, though, most of crypto to date has been really people in crypto, people doing things inside crypto and that were separate from their regular lives. It wasn't people usually. Most of crypto use to date is not people that were paying their grocery bills or receiving their salary. There's been a small amount of that, but the vast majority was people who are buying crypto, selling crypto, trading, buying NFTs, and they just didn't have the same privacy guarantees, Or they were also crypto native, so if they really wanted privacy, they'd go ahead and use some mixer, and they knew how to use the technology. But that's not where we are today. Today, Robinhood is a good example. So Robinhood is building on Arbitrum, and they are giving their customers access to equities on Arbitrum. So if you use the Robinhood app in Europe, you're going to do something on Arbitrum. These aren't users that know anything about crypto. They're getting the benefits of crypto, but they're not using. They don't know how to set up a wallet. They don't know how to store a seed phrase. They know literally nothing. They don't know how to connect to an RPC. That's where crypto is going today. It's becoming back-end infrastructure that's supporting finance and supporting normal people that just have an expectation of privacy, which is exactly the one I said. I'm cool with my bank knowing everything about me. I'm not cool with my neighbor knowing that. And the fact is, these people weren't here a year ago or 2 years ago, but they're very much here now. And I think they'll very, very much be here in the next 1, 2, 3 years going forward.
So with that, I mean, for people who don't know, we are Arbitrum first. We're building our FHE stack on Arbitrum. And we want to put that on every Orbit chain and on the Arbitrum mainnet and basically everywhere. My question to you is, I'm curious, I mean, I have my take, but how do you see FHE fitting into the Arbitrum ecosystem first? What do you think are like what is the use case that excites you the most, if you could pick one?
Yeah, I think probably the most exciting use case, often the basic ones are actually the most exciting. So payments, private stablecoins. The idea that you can just have private payments is going to unlock so much for so many people. Because when we talk about what most people are doing on the blockchain today and the normies, the people that are institutional customers, generally it's some form of payments or exiting or entering positions, so which are also basically roughly just transfers of tokens and capital. So actually that's the one that excites me the most. I think the sky's the limit. We can get super complex in the protocols we build that are, can do much, much more advanced things. And I think those will have their time and have their place. But actually, I think the simplest one, and you know better than I, it's not simple, is going to be the one that probably has the largest impact in the near term.
I completely agree. And obviously that's the focus of us. I'm glad we're aligned. A personal question. So you've a little bit. So you've been, again, even before Arbitrum, you're a cryptographer. You've done a lot for privacy tech. For those who don't know, Steven is basically why we have proper self-custody at scale today, in my opinion. But something got you into privacy tech. I mean, you did your PhD on MPC technologies and those things in Arbitrum. So as a human being, as a person, what do you do to keep your privacy, and what do you do to increase your own privacy? What do you care about, what you don't? And just to be clear, you don't need to tell us how you keep your seed phrases. I mean, maybe you could tell that to me later, but not publicly.
So my take on privacy and why I think it's so important is not because I think it needs to be forced down everyone's throat, in the sense that if you have something that you don't think needs to be private, I'm not here to tell you, like, no, it does. Like, if you, unlike me, like that Venmo feature, like, go right ahead. I'll scroll through your transactions. It'll be great. We'll, that's the thing, if that's what you're into. But the thing that for me is I like actually living, a private life. And private life, and I think the thing that really got me into it was there's this notion, which I hate, which people say, oh, if you have nothing to hide, why do you care about privacy? It's like, what? Like, I could be a good person and not committing crime, but also just don't want you to know where I'm buying my groceries, or that I paid another parent in my child's school to get the teacher, a gift. There's just so much that you can learn, and particularly in today's day and age, when it comes to just thinking about how do we protect ourselves and protect our families, right? There's a lot of scary things out there, and people that can take a little bit of information and learn a lot. So to me, actually living a private life is, very important. Obviously, I'm in the public life a lot, public light a lot, but I do believe that everyone should have the tools. And again, that's my personal take. But I think the thing that I'm passionate about is everyone should have the ability to choose where they want to be on the spectrum, and no one should be forced to use a system that exposes them in a way. I believe privacy is just a fundamental right that we all have and all deserve. And that's something that shouldn't be compromised. Whether we want to exercise that or not, or we want to voluntarily give up our privacy, that's totally up to you, and not for me to tell you what's right and what's wrong.
I think this is a beautiful way to wrap this. I only have one more question for you. Why Phoenix?
That's a great question, but it's also an obvious question. First of all, I've known obviously you for a long time and respected both your work in Phoenix as well as your previous MPC work as well, and definitely been a long-term fan. But when I look at the team, using FHE is an extremely promising technology that we can actually get a lot, but it's also extremely difficult to put into practice, right? So we're kind of on that curve now where we're actually seeing things that I really never imagined would happen. I remember when I first encountered FHE was shortly after the initial Gentry paper, but when I was started my master's at Columbia years ago, and this was one of the first technologies that I took, and I took a class with Shai Halevi back then on FHE. Unfortunately, I don't remember any of it, so don't ask me any technical questions. But the idea is it's extremely complex, but it's also extremely powerful, and that's not an accident. Those two things often go together, and we need a serious team of practitioners that merges both the theoretical as well as the practical capabilities to take this theoretical technology and bring it into the public domain and actually make it usable. And I think if you look at the makeup of your team, I mentioned Chris before, obviously on the very theoretical, probably the most respected Lattice FHE researcher that there is, and all the way up to the engineering team. I think that you guys have the absolute best shot that there is to bring this technology public. And I also think that we're very excited about it, and we're going to lend everything that we can on the chain side and on our technology side to bridge these things together and bring this public. It's an exciting task. It's a monumental thing you guys are taking, but if I had to take a bet on one team, and in fact, I in many ways have taken a bet on one team that will bring this technology to light in public, Phoenix is the way to go.
Stephen, thank you very much. Everyone, a round of applause to Stephen, a true legend, really.
Thank you.
Thank you for coming here.
Something else, but the user doesn't want to reveal to the service the whole photo. So the photo gets encrypted and it's sent to the service, and then the service tries to see whether there is this particular feature like Eiffel Tower on the photo. So this was about Web 2, but Web 2 is relatively simple compared to Web 3. Because in cloud use cases, like on the previous slide, FHE protects users just from a single service provider, and computation happens on a single server or maybe in a single database, a data center, and only the user holds the secret key, so only the user can actually do the decryption. While in Web3, many parties contribute encrypted inputs, and many entities verify outputs, and nobody trusts each other. So there are issues if you want to deploy FHE in Web3 environment. And perhaps the first problem is, so if you want to run FHE on chain, things get much slower, and the latency is increased, the cost is increased. So for example, the gas costs is increased because ciphertexts are large. We're talking about hundreds of kilobytes, and latency is increased because the error, which is an inherent part of the FHE that we know today, error is always part of the ciphertext. And if you multiply two ciphertexts, which both have an error, then this error gets multiplied as well. So it gets increased. And every couple of operations, or maybe it depends on the scheme, maybe after every operation, you need to reduce this error. And this is called bootstrapping. And this is a very time-consuming and expensive process, which increase the latency. And also, because the storage is increased because of these large ciphertexts. So for these reasons, current FHE deployments actually use hybrid architectures. So only some part of computation is done on chain, and the actual FHE computation, the heavy computation is done off chain by something that is called usually coprocessors, which run usually some accelerated hardware. But of course, as this is Web3 and we need verifiability, you also need to somehow make sure that these coprocessors actually did the computation correctly. And how it's done today, it's mostly that there's another component which checks
El
that
centro de atención con
all
Spotify
these
Premium.
coprocessors
Crea, personaliza
return
y
the same
escucha tus
result, or
playlists
at
sin
least most of them
interrupciones
return
en
the
modo
same result.
offline. Disfruta 3 meses gratis ahora y cancela
So
cuando
the
quieras.
second problem
Toca el banner para
is
obtener más
trust and key
información.
distribution. Because in centralized settings, the user holds the secret key, the server only sees the ciphertext. So with the use cases on the first slide, only the user knew the secret key. So the architecture was relatively simple. But in decentralized networks, there's a question who holds the key. So for example, if each user would have its own key, then multi-party interactions are difficult to achieve. So for this reason, something it's used today that it's called threshold decryption, where a group of entities have shares of the secret key, and they need to collaborate together to, or some group subgroup of this group needs to collaborate to do the decryption. But you can imagine this brings other problems like performance and trust. And the third problem is programmability and composability, because Web3 contracts are composable. Contracts call other contracts. And in the FHE world, you can imagine each smart contract being a separate FHE circuit, and these circuits might have a different number of operations. The depth of the circuit is different, and for some FHE schemes, different depths require different parameters. Or for some schemes, you will need to know beforehand what's the depth of the circuit. But yeah, despite all this issue, I think that Web3 is actually the space where high-end cryptography like FHE is deployable and can be deployed, because it's not that deploying crypto in Web2 is impossible, but it's the release cycles are long, and there's low tolerance for performance degradation. There are proprietary stacks, while in Web3, developers are comfortable with new technologies and the ecosystem experiments rapidly. Most of the things are open source. Users expect cryptography to be part of the tech, and protocol upgrades are frequent. So if FHE is to be adopted somewhere in the future, I think it would be Web3 actually. And indeed, there is a huge FHE momentum in Web3 right now. So, for example, for confidential compute layers, we have Phoenix, Enclave, Inco. Then for FHE runtimes and compilers, we have Zama, Sunstream, Phantom Zone. And for fairness and MEV resistance, we have Shutter Network and flashbots, and many others actually. And there's a good reason for it because there are many use cases for FHE blockchain. For example, the private stablecoin, where users could mint, hold, and transfer stablecoins without their balances and other details being public. And, or perhaps confidential lending and borrowing, where users deposit collateral and take loans, but neither of these data is visible to the public blockchain. Then private automated market makers or still bit voting and so FHE EVM, which is a fully encrypted execution environment where smart contracts operate on ciphertexts. And there's also another class of FHE use cases in blockchain, which is perhaps more suitable for L2. So, for example, private clustering. So, for example, computing classes of for user behavior, transaction flow, or maybe for forecasting, for yes, price spikes or liquidity demand, and actually many others. But it needs to be noted that the arithmetic for these cases is actually very much different compared to the arithmetic needed for the use cases in the previous slide. Because, for example, private stablecoins require exact arithmetic, exact integer arithmetic. So, for example, for private stablecoins, you need to check whether some amount is smaller than or bigger than the other amount so that the user has enough amount on his account to be able to transfer it to some other user. And there is no tolerance for error. While for these FHE use cases, there is actually tolerance to some numerical error. And other schemes can be used actually for these use cases that are related to machine learning. And if we talk about machine learning and AI, I actually heard quite a few times these days about the possibility of Ethereum being the facilitator to ensure that AI models are executed correctly. And I actually hope this turns out to be true in the future because there are many use cases. So, for example, for finance, investors could run risk models or portfolio analysis on sensitive financial data without revealing the details. And how FHE help here is just in a way that this data is encrypted, and the blockchain, the Ethereum, can help here by ensuring that the model is actually executed correctly. And similarly for auditable financial predictions, or perhaps another use case, collaborative training, where multiple organizations jointly train a model on encrypted data. Yeah, so there are in general two classes of use cases, and not surprisingly, also actually FHE can be divided in two classes of operations of schemes. So on the one side, there is integer FHE, schemes like TFHE, FEW, BGV, and BFV, which are suitable for exact computation, integer arithmetic, are more suitable for L1, and also bootstrapping enables unbounded depth because, for example, in TFHE, you do the bootstrapping pretty much for every operation. So there's, you remember when I was talking about smart contracts being FHE circuits of different depth, this is not a problem or not such a problem for integer FHE because bootstrapping is done for every operation. And on the other hand, we have approximate FHE, so mostly CKKS and its variants, which is more suitable for machine learning because it's based on real and complex numbers, and also very much vectorizable. So it's many things can be executed in parallel, thus faster in some regards. And what's interesting is actually, and kind of surprising, that you can do the scheme switching. So for example, if you want to do a comparison of two numbers, whether the two encrypted numbers are the same, this is actually non-trivial in FHE, but it turns out that for CKKS, it's much more complex than as for TFHE. So if you want to, for example, compare two encrypted numbers encrypted by CKKS, you can do something that it's called scheme switching. You actually convert the ciphertext to TFHE ciphertext, and then you execute the comparison of two numbers there. So you can take, in a way, the best things of the both worlds. So yeah, despite all these good things about Web3 and FHE, so a lot of players, a lot of use cases, and all kind of different schemes that support different use cases, there are still problems, of course. Some of them I already mentioned, so like key management. So for example, this threshold FHE decryption. Another problem is correctness. So because of this error, this is part of the ciphertext, there's always a slight possibility that the decryption goes wrong. That means that the decryption returns the wrong number. And usually, in a lot of cases, this probability is set to 2 to the minus 32. But this can be problematic for Web3 because just because of the nature of the system, because there's a lot of operations and an attacker could observe a lot of operations. So for example, the attacker could try to construct a ciphertext where the error is very close to the margin, and then the attacker could send this ciphertext to the system and observe some strange behavior, and by some strange behavior, maybe they could actually know some things about the hidden balance or things like this. So the parameters need to be actually chosen to support probability. The error of probability be something like 2 to the minus of 128 or something like this. There's also verifiability, of course. As I mentioned, the current architecture, the current systems have verifiability in a way that a special component checks whether coprocessors computed the same result, but ideally, of course, we would have proof of correct execution using verifiable FHE, VFHE. So what could be potential paths forward? Well, despite all of these progress in the last years in the FHE area, it's still FHE still brings a lot of overhead. It's still running on an expensive hardware. So sustainable economic models needs to be somehow designed. And then, of course, verifiable FHE probably needs to be advanced. New ways to do the decryption could be explored. So, for example, multi-FHE instead of threshold decryption. And personally, I think also that a community would actually benefit from kind of open benchmarks, which would make the community know which teams are better, which use cases, what's the overhead of scheme switching, for example, and things like this. Yeah, so if you're interested, there is a long write-up on if research about these topics, and yeah, probably there will be more to come. So, thanks.
Thank you to Mia and the Ethereum Foundation. Next up, we'll have Optalysis. And yeah, thank you.
Yes. Hello. Okay. Hi, everyone. Thank you for that little waiting for the tech to work. So my name is Aditi Veerkanam, and I work at Optalysis, and I'm a product manager there. And I'm here to talk to you today about how we are using our hardware acceleration to contribute to the FHE ecosystem to make it a practical solution to build with. So, who are we? We are a deep tech company, and we are based mainly out of the UK, but we have some colleagues abroad as well. And we are specialists in photonic computing. So what that means is we have an amazing team of photonics experts who are building a chip using light to do maths so we can speed things up. What that means is we can do a whole range of applications with this solution, but the one that we are starting with is accelerating fully homomorphic encryption. The reason being was referenced kind of in the talk previously, actually, which is that it's a fast-moving space. We think there's plenty of opportunities to innovate. Developing photonics takes time, but we want to play around with solutions in the intermediate space, which is why we are here today in blockchain. We have built our first product, which is called Light Locker Node. Our team is out there outside to talk to you more about it. And that is a hardware accelerator using FPGAs, field programmable gate array chips, to provide an initial product to solve the problem of FHE acceleration on our path towards developing a solution using photonics. And our goal really is to contribute to a world of secure computing, but to solve key problems for key customers. So the first problem that we're starting with is the privacy gap in blockchain. We've heard a lot about it this week, which has been really quite cool. This is my third Web3 event, and it's definitely the most I've heard about privacy in my time here, which is pretty amazing. And I think the thing that we're getting from this is that we need a whole range of solutions for different stakeholders in this space. And what that means is we're going to need real solutions, a variety of solutions for different applications in different contexts. So for individuals, we should be able to choose what gets revealed to whom and when and why. You probably would not hand your banking app over to the person next to you, but you might need to prove your identity to someone if you're trying to rent a house. So therein lies the nuance and the difference in what you want to provide to whom and when. Next up is for institutions. We've heard a lot about how we want to get institutions using blockchain and adopting blockchain, but at the moment, the transparency means that their business strategies will be revealed. It's a bit prohibitive. So we need something to help to bridge that gap to get institutions on chain. Also reduce the increasing risk of data breaches. We keep hearing about how we're losing, billions of dollars to data breaches all the time, and we need to solve that problem. And the increase in data breaches, all of that results in more oversight from regulators, a greater need for compliance. But we want to solve that problem without blocking innovation, right? Without slowing things down. So we need to find privacy solutions that can help manage all of those things. So the common thread here really is that data is the most common element here. It's the most valuable asset for all of us for different reasons in different ways. We need to be able to protect that data, not just when it's being stored, not just when it's being shared, but also while it's in use. And fully homomorphic encryption makes that possible. So again, we've heard about how we need a mix of solutions, we need verifiability, we need things to be confidential. I guess what I'm here to stress is that I'm not here to pitch FHE as the solution to everything all the time. I think it's important that we use the right mix of technologies to solve the right problems, just like you would in any other engineering problem. So we're here to say that it's a feasible member of the party now under the banner of privacy enhancing technologies. So just to kind of put an example together here, one that I'll be using throughout is an encrypted token transfer. So you might encrypt that using FHE, it was just referenced in the previous talk, and then you need to verify the fact that it's valid, and you could do that using ZKPs. You might wish to run this within a trusted execution environment for an added layer of security. And then you need to be able to have them on chain. And also you might wish to run your decryption using MPC, for example. So yeah, this is just to illustrate that we're going to need a whole range of solutions to solve our problems. And I want to emphasize that they're complementary, not competitive. But also what I want to stress is that we can now consider FHE a genuine member of this party of solutions. And we're building the hardware acceleration to help that happen. So some of the challenges that we've talked about already. The first being ciphertext operations are pretty chunky, pretty heavy to run. And so we're solving that by deploying custom infrastructure, which is tailored to FHE workloads. So again, thank you so much for the previous talk, because it's referenced quite a few of these things. But we're doing the hard work to make sure that we take those parameter choices into consideration. We're partnering with other people in the FHE world to make that more easier to deploy, right? And so we're taking the pain of that and creating hardware to make this possible. The second is, it was also referenced, the power consumption and therefore cost. So again, our hardware solution is designed to take the burden of that away. We're distributing the computation workload over CPUs and initially our FPGAs, but in future our photonic capability, which will significantly reduce the amount of power that's required, making it a genuinely cost-effective option to be able to run. And the third one is to integrate with existing infrastructure. FHE solutions have required specialized cryptographic knowledge. It can be seen as a bit tricky to integrate into existing infrastructure. And again, we're trying to collaborate with our partners in the ecosystem to take that pain away from you so that applications can just get on and be built, and we're tackling the hard bit under the surface. So what does that look like? We had our box for anyone that saw us at EthCC. It is an actual box. So it is a server which contains 3 FPGAs currently and will in future be upgraded to include our photonic chips. We're running it on a Dell server. And so as you can see from this, you probably don't want this in your living room. So we are aiming this at institutions, enterprises, node operators, data centers, for us to be integrated alongside your FHE co-processors to make that infrastructure simple, easy to deploy, easy to use. But I guess I just want to say it is real, it does exist. And so I really want to encourage developers to kind of see us as bridging that gap to being able to build with FHE as a reality. So for anyone that's come and talked to us at the stand today, you might have been shown this diagram already, but hopefully this just helps place us in context. And so the hardware I showed you on the previous slide is what sits right at the bottom of the stack. So we create the hardware, the chips, and then we've also developed an API, which we will be making open source so that you guys can kind of get your hands on it. And that is tightly integrated with the FHE schemes. So again, it was referenced in the previous talk. There are a few different FHE schemes which you can use. So you've got TFHE, you've got CKKS, BGB, BFV. We will be integrating with all of these schemes through their libraries. So initially, we are integrating with the TFHE scheme because Zama is, so active in this space. We thought it was a natural first step, but we will be integrating with these other schemes, and we are doing projects at the moment within Optalysis to do so. And that then is coupled with the FHE providers who run the co-processors. Again, this was referenced in the previous talk. So you have companies like Phoenix, like Zama, who are running that compute off-chain, and that's where we integrate in. So at the moment, Optalysis integrates with Zama's TFHERS library and their coprocessor. Above that sits all of the FHE tooling and the libraries to make deploying into this ecosystem as easy and seamless as possible, and you can then deploy onto your target chain. So yeah, right now we sit down that side, but we are doing all the work to become as agnostic as possible and open up our hardware to make sure that encrypted compute really is as easy as possible. And shout out to all the other players in this space that are making this possible, because we need to work all the way up. So now you've seen where we sit at the bottom of the stack. I'll just talk to you a bit about what exactly it is that we're accelerating. So again, in the context of an ERC20 token transfer, what that does is break down into a few different FHE operations. So greater than or equal to, add, subtract, and a update. So again, this was referenced previously. The main computational effort for TFHE comes from the programmable bootstraps, which are there in order to keep the noise levels maintained such that the ciphertext doesn't become useless. And that is the specific element that we are accelerating with our hardware. We wanted to take the most painful part of that problem and apply our solution to it. So what that means is running that computation can now happen with significantly less latency than it would have done previously. So to talk a little bit more about performance, we heard about GPUs. So this is what our performance modeling is comparing our hardware against. So the gray and the blue is our light locker node, which contains 3 FPGAs. And we are comparing that to two NVIDIA H100 GPUs. So we've really designed our hardware to be optimized for scale. Like I spoke about at the beginning, we want to make sure that we're building practical solutions that are going to enable privacy on-chain for a whole range of different audiences. And we understand that if we don't tackle performance at scale, it's still going to be challenging for people to want to build on it. So what you can see on this graph here is that at lower numbers of transactions, the latencies are pretty similar to the GPUs. However, if I go on to the next slide, what you can see is because of the way that we have implemented batching on our hardware, we can make the most of parallelization that's available, and we can therefore run, so if you go to about 10 seconds in, you can see that we are running almost twice the number of transactions as you could do on a GPU. So really that is to emphasize that we want to offer a solution that can provide benefit at scale for lower power, and therefore more optimized for cost. So really trying to tackle those problems for using FHE in reality. So whilst we've been developing this product, the conversation around performance and applications comes up a lot. People ask a lot about that. And we really found that the answer had to be, it depends in a lot of cases. It depends what application you're developing. It depends what workload you want to run at. It depends what your infrastructure is. And that was quite a tricky conversation to navigate. So what we've done is we have developed some of our own tools to help us tackle that problem, but also to facilitate conversations with customers, with developers, with people in the ecosystem to help translate FHE to become a reality. So the first one began as a journey in our own engineering team. We're pretty new into the Web3 space at the start of this year. And so what we decided to do was rebuild the Zama's FHE VM environment and deploy it onto our own private L1 blockchain, which is connected to our hardware accelerator. So we now have the ability to run FHE smart contracts on an L1 chain to be able to have those more informed conversations, to be able to show what the hardware acceleration can bring to the party, and also for our own learning. So I know it's a bit teeny tiny, but this is just really to illustrate the point. So this is and just running a really simple example on our testnet. So this is encrypting a single integer, putting that onto the chain, including it on the block, and then you can get the ciphertext back and decrypt it, basically showing, in simple terms, it can happen now, and it's happening now, running on genuine hardware acceleration. The second example is adding 2 encrypted numbers together. Again, super simple example, but just to show that it can be done. So I guess our takeaway from this was then there's a whole range of different applications you might want to play around with, and there's a whole load of different performance implications that come with all of that. And so again, our next deep dive into the world of developing with FHE is to create a performance model. So again, it was referenced at the end of the last talk that more open source tooling can help to progress things within this ecosystem. So we'll be looking to make this open source as well. So what we've built, and you saw the charts of the output of that running earlier, is the ability to read into our model. You can specify the hardware that you want it to run on. So for example, our LightLocker Node 1300 running 3 FPGAs. You can specify your batch size. So you might want 1,000 transactions, for example. You can import your Solidity contract. And what our model does is then break that down into those FHE operations, break that down into its programmable bootstraps, and then give you an estimate of your performance at the end. So really what that does is help to bridge that gap between what you're developing, what the application is, in the context of real infrastructure, real hardware, and then what performance you can expect to get out at the end. And we wanted to make that because I guess when you're developing solutions, there might be trades you want to make. You might want to adjust the complexity of your contract. You might want to experiment with it. You might want to tweak it. So we're hoping that this sort of tooling can really help to contribute towards those sorts of solutions and that development. We're looking to adapt this further. So we're thinking to include other types of hardware acceleration in the back end. So you can do comparative exercises, make it available through a WebAssembly. I'm sure there's loads we can do with this. This is, we're sort of just building this out at the moment. And I guess this is our call for help or contribution from the ecosystem. Please come and talk to us if there's things that would really help for you guys to make FHE a reality and develop with it and understand how hardware can impact your development. We would love to talk to you. We can build this out further and make changes. So in summary, blockchain needs privacy. It needs a whole range of different things. It needs different applications. It needs a variety of solutions. And we're here to say that FHE can now be considered a real member of that party for you to develop with because we're tackling that hard infrastructure that sits underneath the hood. We're building the tools and we're building partnerships and collaborating within the ecosystem. So we would really love to talk to you. It can be a bit tricky as a product person sitting at the bottom of the stack, feeling slightly disconnected sometimes from users and applications. And I don't think that's an uncommon feeling in the privacy space. I think we all need to help each other. So I'd love to talk. Hit us up on Telegram. Joe, my colleague, is doing another talk later on a panel, I believe. And we have a stand out there. So we would love to chat, love to hear from you. And thank you very much.
Thank you all. Next up, we have a panel on FHE as a trend or new era in Web3. So yeah, thank you.
All right. So this panel is called Privacy as a Hot Topic. Is it a trend or a new era in Web3? I think we all noticed that suddenly all over Twitter, all over every social media, privacy tokens are actually doing quite good compared to the market. And it's really interesting to understand why and what's happening that this is finally turning into something we all waited for. So before we start, let's do a quick round of introduction.
Hello, it's Furkan. I'm working as a researcher at INCO, coming from a mathematics background in cryptography, particularly in FHE and ZK, and I'm very happy to be here.
Hi, my name is Jan. I'm the managing director of Solidified and the co-founder and managing director of Oak Security, cybersecurity firms that are leading the edge in the industry.
I am Dr. Richard Carbeck. I'm a cryptographer that's been doing post-quantum crypto and privacy-enhancing crypto for my entire career. I'm from Quip Network. We're building the world's shared quantum computer.
Hello everyone, I'm Jonathan, and the head of product of Phoenix, which is building privacy preserving solutions. And in total, in the past 5 years, I'm working on that aspect quite intensively.
Hi, I'm Kai. I'm a contributor to Railgun. I've been contributing to a number of different privacy protocols, and I think we're all here because privacy is sort of important to us.
And I'm Yoav. I'm the community manager of Phoenix, and I'll be your moderator for this panel. So bear with me and hope you guys enjoy it. So before we start, I was said before, we're seeing that that finally people are talking about privacy, and finally privacy builders are feeling comfortable to show their product out loud, and people are actually interested in it and understand that this is something we need. Why do you guys, and we can start with you, Jan, why do you think this is happening? Why do you think this trend, or hopefully not a trend, is finally taking place?
I see three big reasons. One is privacy is a fundamental human right, and we need to accept that we need privacy on chain. The second is a very commercial reason, like institutions are moving on chain. The big institutions are looking now into Web3 technology, and the technology is ready. And I think for them, they know that their customers, they want privacy. And that's very simple. And the third, and that's the most important for us, cybersecurity and privacy go hand in hand. We cannot have cybersecurity without privacy, and we cannot have privacy without proper security. In Germany, we even have a word that is called Datenschutz. That means protection of data. In Web3, all data holds value. So if your data gets wrecked, you're broken.
And I know, Ben, that you come from quantum computing.
Oh,
yeah, sorry. Rick, sorry, my bad. You come from quantum computing, and do you think, out of fear of what quantum computing can bring of us, this is one of the reasons we're trying to fight it out loud and migrate and create more and more solutions against it?
Yeah, so there is a very real visceral fear that quantum computers are going to end the entire world. I'm here to tell you, as the proprietor of quantumdoomclock.com, that is not the case. I do think it's most likely going to be more like a Y2K scenario because of all of the recent technological innovation, the newer algorithms that have come out. And the biggest effect is going to be it will increase the price of how much computation you need to run fully homomorphic encryption algorithms, because they're going to have to be upgraded to newer techniques like using super isogenies and things like that. To more directly answer your question, I mean, as a cypherpunk, this has been around my whole life. It started out in the 80s with writings from David Chaum, which are still online. You can go to chaum.com and read some of the things he wrote, where he viscerally understood the world. For those of you who have seen Black Mirror, right? We live in this dystopia when it comes to privacy, with all these data vampires sucking down all the data and then using it against us. I think people are finally becoming aware. In the 90s, you had the Cypherpunk Manifesto. I would encourage everyone in this room to read that as well. And it's, where have you all been? I'm glad to finally see people starting to take this seriously. I'm really impressed to see the projects that have come around in the last 2-3 years that are taking this seriously and moving things forward.
Thank you. And you brought up FHE, and I think beside of the fact that obviously I'm biased and yeah, I can't hide it, but do you think that one of the things that blocks us to make it adopted, the privacy solution get more adopted, maybe not only by Web3 people, also but normies, is some way, and that's kind of a problem of crypto in general, like terrible UX or terrible interface with the user itself. I'm asking you, Jonathan, as product, how do you think we can solve that or make it easier for people to understand what we're actually trying to build here?
Yeah, so in the past 6 months, I ran quite a comprehensive product market fit research and interview a lot of people to understand what their needs, pain points, and to better understand how privacy can fit in and help. And while most of the people, especially if it's like retail users, retail traders, saying that, transparency is a given, privacy is not feasible, and I'm fine with that, when I dig in, I realized that most of the people like holding 10 to 15 different wallets and trying to keep it unlinked. And for what reason? Like basically compromising their UX in a terrible, terrible way, in the most inconvenient way. And the reason for that, I guess, is because they want to gain some privacy because everything is transparent. So transparency is a given, privacy is a problem. So to your point, UX is super important for adoption, for sure. I don't think that was like the blocker. It's about adoption, it's about education, and it's about trends. Like, this industry is all about FOMO. We just need to start rolling this ball of the hype and people will join. Obviously, I'm biased, but I think that privacy is also like great signals for the maturity of the market and for the fact that people are actually looking for building more mature stuff and basically opening up like the next generation of applications on blockchains using the tech that is quite amazing, but transparency for everything when it's like a compromise any confidential or sensitive data of the user is like a price that is too high in some senses.
So you brought up the word hype, and obviously, yes, as you said, in Web3, everything is about FOMO and about like catching the next trend before it's too late and trying to make the flip before everyone does it on you. How can we notice if how can we actually understand if this is actually just a hype and a trend, and then people are going to move to the next one, which can be, I don't know, educational solutions on Web3, or actually a cultural changement that we're doing because of different reasons?
Yeah, very good question for me. First of all, I don't think privacy did explode so far, yet, actually. Yeah, there is a trend and people is talking about privacy, which is really great. But to make it explode, I think we need two things. First, I agree totally. Like we need to have a very good privacy UX. We don't need, we shouldn't be using separate wallets only for privacy. I mean, this is what I think at least. And the other thing is where Web 2 and Web 3 agree in terms of compliance. Because even though seeing many privacy protocols is totally great, reading white papers, reading documentations, and seeing very smart methods of bringing privacy to Web3, compliance is another reality. If we're gonna make the method option, if we're gonna bring privacy into, like, let's say, daily billions of transfers in private on-chain transactions, then we need to also solve this like compliance problem as well. And this is not something we can solve internally within Web3. This has to be done between Web3 and Web2 to also bring enterprises into on-chain. And that's why I think the day these two happen will make privacy explode.
I'm asking you, Kieran, based on what he said. First of all, if you agree with what he said, what do you think we should do and change in our beautiful ecosystem in order to create that structure? Do we need to create some sort of educational change to make people understand why privacy should be more than just a trend and something you should desire and aim for, or it should be more of a institutional changes to try to bring those big players that would basically kind of push it on you and you understand that you need it? Because we know that privacy is something you appreciate just from the moment you lose it. So is that, well, how do you think we should change the culture to make people actually appreciate and push for privacy?
Yeah, well, I think the unique thing, right, about being at a conference like this is, we don't really need to like go off and we're trying to find some like weird, oh, this is going to be the killer use case for privacy, right? We can just kind of walk around. There's, if anyone's been to the World's Fair venue, right? There's plenty of booth over there, right? There's probably something like, I don't know, over half of all the like aggregate, social valuable or social value provided by DeFi that's probably represented in that room, and so we can see what people want to do with like DeFi and all, and if you want to like go and build like, let's say, private DeFi capabilities or whatever, well, I think the thing is like, okay, we can't really sit here and talk about, well, what would people want to do with private DeFi? I think, well, you've got to look at what are people really doing and like enabling a private method for that to be possible.
So that's a question for everyone, and whoever want to answer, just take the mic and answer to it. Yes, we can see in the market that there's a lot of privacy solution, there's a lot of new product, and there's a lot of new companies working on privacy. Privacy, especially for us that are part of this ecosystem and want to stay in this ecosystem, believe in it. I don't want to look at privacy, and I hope none of us does look at privacy as a big trend like NFT was. And when NFT was popping, you had companies starting like water. Every day you had 5,000 different new projects. How do we make sure this is not just a trend, and then next time everyone's going to move to the next one and privacy tokens are going to crash down and no one's going to care about it, and we're going to start talking about, I don't know, the next hopefully good trend?
I can
First,
thanks. So it's a good question. Obviously, we're super happy to see this hype about privacy, for sure. But hype is also a risky thing. You mentioned NFTs. I think that if you're taking NFT as a piece of technology, it's quite amazing and has a lot of utilities. Taking NFTs and basically building generative art with that and just selling based on the rarity rank, like, not stupid, but like images of whatever, is basically misleading, miseducation of what can be done with NFT. So same for privacy. I think we should take it very seriously, the hype, in a way that we won't like abuse it, right? But I do think that privacy is not sexy. Privacy is not about doing like 100x on your money. Privacy is about providing super important primitives to build applications that require privacy in some matters. I'm not saying like we should encrypt everything, but to build more mature use cases and open up use cases that currently are not feasible because everything is transparent. That's what privacy should do. It should be like an enabler for the next generation of applications. So,
Well, yes, and you. What we're seeing that is different from history is a lot of the products coming out are, privacy is a feature that is added onto a core. And for a long time, I built many products where that was not the case. We bought those of you who are familiar with the story of Signal, right? They're still not the dominant messenger, and they're giving that away, right? And that's because the privacy is the product. And I think people need to move away from the privacy being the product and then figure out what people are already using and then say, look, you can use this and it has more privacy and it protects you better. I think that's a much better message when you're talking about customer acquisition. I think the other thing that's critical that we do that we may or may not be doing right now is trying to figure out what are the workable business models so that you make money and sustain yourself. A lot of times we build the product and we think, oh, the people will, or the developers will come. If you're building a network and you're not giving away a significant portion of your network tokens to developers and essentially grooming that community to figure out what needs to be built and what's going to be most high impact for you, you're probably making a mistake right now.
I think I agree with what you said, that privacy shouldn't be the product itself, and that links to a lot of privacy solution that comes out there. We're not selling privacy to the client. We're not giving you the best product. We're building a privacy solution that infrastructure are going to use in their protocols to give you a certain product that's secured, and that's very important to understand. That one of the theories that people are getting interested about privacy right now is because we see a lot of very technical, sophisticated product coming out. And then we have this negative, natural understanding of like, okay, if they can do this, I need to find something to fight it, to protect myself with it. So what do you guys think of that perspective about like the reason privacy is getting so sexy? Any one of you guys?
Yeah, I mean, I think this also does tie into sort of the points that were raised about privacy not being like a product in itself, right? Privacy is not really like a feature that you tack onto something either. It's something that sort of has to be part of just the infrastructure for whatever like it is that you're using. So you know, if we think back to like very OG kind of chains, Bitcoin or whatever, you know, people kind of talked about like, oh, okay, well, there's a couple of papers, maybe you can do these sort of different schemes that you can sort of like derive some privacy from, but like the conversation around that changes fairly significantly after you know you see things like let's say you know zero coin paper gets implemented in say Zcash or like Monero or whatever, all these different sort of projects, right? The conversation then that you're able to have fundamentally changes. So I think the thing with like what we have now is sure like we can have all these like things that we point at that like maybe theoretically but maybe the conversation that we're capable of having now that say in like the Ethereum or these sort of more expressive chains, the conversation that we're able to have about it is different to the conversation that we would have been able to have about it like 5 years ago, because there's like okay, there's things that you can point at, like if I may say, like railguns being around for almost 5 years now, right, and fairly expressive feature set, and there's things that people can like already, well, people that already things people already use that now you can do privately. So we're no longer talking about, hey, you should, you know, come over onto this little island over here. And the selling point, why should you spend all of this effort to move over? Privacy. It's, well, look, you can see the stuff that you're already doing. Here's how it functions with, you know, this added benefit.
I'm going to go to our last question before we wrap it up. And again, that's a question for everyone. I think that's a question that I would love you guys to also answer to each other and debate about it. I'm going to talk about the philosophical side of privacy because we've been very technical all day long. Who should set up the morals of privacy? Who should set the boundaries? Who should set the rules, the ethics, the thing we believe in? It should be the developer who builds the product. Can he actually be neutral, or he has his agenda he's trying to push? Or the promoter or the institution that are trying to implement the product and the privacy solution, or the consumer, the people that want to say, no, fuck that. I don't want you to look into my wallet because that's not okay. Who should set the proper setting stones of what is right and what is wrong in the privacy field?
Yeah, I can start. I mean, I would start by defining some axioms. Like for instance, I mean, allowing a money laundering is not an option, for instance. Or the other principle would be more cypherpunk, something like the compliance model will not include any disclosure. Let's say it's going to disclose only a proof that any particular account is not, you know, is not connected to a illicit fund. So another, but I mean, all these are obviously will be personal and also depending on the target audience of the product or the protocol. If a product targets the fully enterprise stuff, and they will probably compromise on some moral, let's say, principles. But if it's gonna be super retail focused, completely cypherpunk, then they're probably not gonna care about the possible volume of the internal transactions, but they're gonna focus more on the privacy, the human rights principle. So that's why I find this question quite dependent on the context and on the target audience of the particular product. But as I said in the beginning, I would start by defining some axioms about what kind of things we're caring. And on top of those axioms, we can build our principles. And I guess.
I mean, it's more in a broad point of view. If I build myself a house and the entire house is glass and transparent and everyone can see me naked, that's obviously not private. So not in like per product, but per like this is private, this is not private. I can decide what I want to use because I decide, but what do we define? Who should define it?
Yeah, I really like that question, that analogy with the glass house, because we have to acknowledge privacy has already mainstream adoption. It's just not there in Web3, right? My bathroom has privacy, and everybody understands that my bathroom has privacy. My bank account has privacy. Nobody's supposed to look at my bank account. Obviously, the bank and law enforcement need their way in, but we even can have privacy and a layer of ZK proofs or any other technology on top of that that makes sure that I'm compliant and I'm not, I don't know, violating legal stuff. And I think that answers the question, because like in the end, we need to build products for the people, and therefore the users should decide, or should maybe not decide, but they should give us the indication of how to build privacy products that such that they feel that they can, you know, go to the bathroom.
I will be disagreeable, and I will say that I kind of disagree with the framing, right? So I'm a bit of an absolutist. I think when you're talking about KYC and AML, that's the wrong conversation to be having. I believe that you should have digital sovereignty. And what that means is the user has absolute control over their data, and they have all of the power. And I think we should build the technology around that concept. So when we're talking about, just to revisit, and I think we probably agree on 110% of the things that we're going to talk about, but I just, on the framing, that's where I disagree with a lot of people. And it's because, and if you're going to talk about KYC and AML type activities, I think it should be entirely on the user. You have the client side doing the verification, saying, is this like a citizen from a country I'm not allowed to do business with? And then you keep all of that behind the screens of the clients. And for me, it really boils down to the question, who should be able to use money, right? And I'll give you some examples. In the UK, if you have certain political beliefs, they take away your right to a bank account. There are people, you can go look online, UK lost access to bank account. You'll see a few dozen examples. The one I'm aware of that's sort of most prevalent recently is a teacher who has some ideas that I don't really agree with, but I also don't think that he shouldn't have access to his own money. He lost, I think, like several $100,000 in his savings, and he can't get it. Another example in the last 5 years, I know a couple of you are from Canada in here. Do you remember the truckers? A couple people remember the truckers. They took away their bank accounts. It's crazy. In Cyprus, they decided to take everyone's bank account and take 10% out, or it was more than that, I think 15 or 20% out. That was a decade ago. These are things that should not be happening in the modern world. And I think digital sovereignty is really where you should be thinking about it and how you should be characterizing every discussion you have about this topic.
It's hard to be, answer after your
Good luck.
This one. Yeah, I will try to keep it short. The way I see it, privacy is not about hiding the data. It's about, by default, defining the sensitive and the personal data of users private. And that's, first of all, that's like a moral or ethical declaration. That's about the ethical logic that stands behind it. Now, specifically for the question, I think that it's always a tricky one. Like, anyone should be responsible for his actions. That's always true. But also the ones that build the tech and build the platform need to keep in mind how we can make the data more accessible, to provide all the information that the end users need to take the right choice. And they will be responsible for that. But the responsibility is also about the tech providers. And lastly, I think that the ones that need to keep to define these ethical and or moral rules are the ones that provide the privacy. Basically, we need to work together to create some standard and some guidelines that we should follow. And that's relevant not just for the ethic part, but also for the technical standard and whatnot. Like, we need to collaborate, work together to make it more accessible so people can adapt it and it can be scaled.
Thank you very much.
Sure. So the original question, I think, was like, who should decide or I might paraphrase here a little bit, but who should decide, how these privacy things work or whatever, right? And I think there is a little bit of a trap that we can fall into if we like examine things this way, right? We can't really go and say, well, I'm going to have like this one group go and decide how these mechanisms function and expect things to work out. Probably the worst example of like the worst thing that we can fall into with this is like we sit there and we're like, okay, well, we're going to decide how this is all going to work, and we sit there talking theoretics, whatever, and like never actually end up with anything existing. And I think we can like agree that objectively, going from 0 to 1, right, then to 2, 3, whatever, right, is better than saying, okay, we're going to go from 0 to 100. But then like never making the first jump. So I think when we're like talking about like these like designs and all, this is sort of like a very important thing to keep in mind. And then building on that, I think like the process itself. One, privacy is very like contextual, right? So for example, the way that I would interact with like a healthcare provider is going to have very different parameters around it than like the way that I interact with like I don't know, someone that I've met for the first time at a conference. There's very, very different information that I'll be sharing with those two people. And like the fact that privacy is very context dependent like that also kind of results in like the decision making process being very context dependent, right? So like who sort of shapes that will depend on the context. I think maybe like the best approach here is sort of this like iterative approach. Well, we can go and like actually, rather than trying to think about this in theoretics, well, why don't we like have something, and then we can be like, oh well, who's using that? Well, now we can have a better conversation about, well, okay, well, this is who's using that, what are they using it for? All right, how can we now improve upon the design? And like, this is probably like a much better approach, and will actually get us somewhere rather than trying to think about how do we design the perfect X.
Thank you very much, guys. We're going to have to wrap it up. We have another panel coming up with Jeremy, James, and Amin. Thank you, guys. Hope you guys enjoyed it.
Thanks, everybody.
Thank you so much.
Stop. We were. I got to the
Oh. Iran. Shalom.
B, let me know when to start. Oh, okay. Hello, everyone. I have the pleasure today of conducting this lovely panel with two very distinguished people in the crypto space and friends of mine, James and Amin. So we'll start off by giving you some quick introductions on ourselves. My name is Jeremy Musigi, founder, CEO of Exosphere. Exosphere is developing confidentiality solutions for on-chain asset issuers.
I'm James. I'm one of the founders from FireEyes. I am probably the least technical by... What am I doing wrong? Not as technical as most of the panels and discussions that have happened today. I think I am a private Ethereum privacy user. If there is any app that has any functionality around privacy in the Ethereum space, I have used it significantly, even just for the sake of using it.
Hello, my name is Amin Soleimani. I'm the CTO of Oxbow. We build privacypools.com, tagline, privacy without terrorists.
Yeah, that's my favorite. So, I mean, let me start by asking you a question. What would you say breaks in everyday crypto use if privacy remains optional rather than default?
Well, let's see. I in a past life, I ran an blockchain-based payment system for adult industry, and I think that that's one of the cases where having all of your transactions be public is probably unwise. And yeah, and many of those cases. I mean, we make fun of people who put their like Venmo transactions on public, right? And so I think anything that isn't like very simple, you probably don't want to broadcast to the whole world. It's all sorts of use cases, like payroll, for example. You don't want how much money your employees are making public. You might not want to share to the world how much all of your folks are making and how much money you have. And every time you pay for anything, you might not want to reveal your entire transaction history and all of your money.
That's what I was going to say too. Is like, I mean, every time we paid each other back in the day, we would use Tornado Cash because we didn't want to like dox our wallets, and there was no other way to do it. You would either wash it through a centralized exchange without KYC, or you would use Tornado Cash.
Indeed. James, what would you say is the strongest ethical case for financial privacy, and what are the trade-offs that come with it?
I think like similar to the panel earlier about like talking about the trade-offs if we are already actually really used to privacy in a lot of our day-to-day actions. It's just that when you go on chain, for some reason you sort of are willing to give that up in its entirety. And that's just become the norm, I think, for a lot of people. And so just the idea that whenever you do an on-chain transaction, you are like your entire pants are down and everyone can see everything. Versus like all traditional banking, which actually like evil actors or the central bank and the sort of and the large and a large bank that sort of has oversight of your transactions, they are seeing everything, right? But it's actually like your friends don't. And so sort of how can we take that same energy and apply it to crypto, I guess?
Do you guys laugh when you're signing up for an event on Luma and it asks you for your Ethereum address?
I mean, I guess that's like a pretty funny way to expose your whole like balance, especially if you sign in with like your main wallet. And also, it publicly lists you as a person, and then anybody can see that you're going, and then like trace the ENS to the amount that money you have, and then decide which Luma events to try to kidnap people from.
Hopefully, no kidnappers in the audience. Right? But
nobody's taking notes, right?
But I also think like even like linking it to your email address is like signing up to a Luma and I've given them my ETH address and I've given you my email address and I've given you my name and I've given you like whatever fucking birth certificate you asked for on the Luma sign up. And like those trade-offs are like interesting, which is why we all just use public addresses with not a lot in it, right? I mean, like luckily James.eth, had some money in it and then I got drained. So now it has less money in it.
Yeah, I lost all my money in a boating accident.
Me too. But like
I was there. I was on that boat. Yeah.
But that kind of energy is, I think, like clearly broken. And we shouldn't be. I want to make a new ENS, which is like James for events.eth. It's like.
Yeah. So I want to ask both of you your opinion. Should privacy in Web3 be on by default, opt-in, or context specific?
Well, I've thought about this some. Privacy by default is like a really nice rallying cry right now. I am cautious and skeptical and hope like somewhat optimistic. So I'm gonna maybe to give a longer answer. Who here has heard of Tornado Cash? All right, everybody. So everybody's aware that like North Korea attacked a video game for like $500 million, put hundreds of millions of dollars into Tornado Cash, right? Cool. So that wasn't great, and it also cast suspicion on all of the other users of Tornado Cash who were not North Korean hackers. And I don't think we really anticipated that that's how things were going to play out. So I helped start Moloch DAO in 2019 and gave essentially the first check as a grant to Tornado Cash and several other grants and funded them. And then when the devs ended up in prison, we made a fund to defend them legally, and they're still appealing their trials. The fight goes on. And so we have had the lived experience of having our tools that we built for ourselves, for our personal privacy and protection, abused by people that we would have never anticipated in ways that we would have never anticipated, and made less useful to us as a result. And so I'm worried that if privacy is by default, then potentially all users of Ethereum would be suspected of potentially being criminals because it's hard to tell their money apart from the criminal money. And our company, we build privacy pools. And so what we do is we have a privacy system where we can monitor the deposits and we can remove deposits. We have to approve deposits. And then even if later we find out that, we shouldn't have, we can remove a deposit. And that allows all of the other users to prove that they are not the money that came from the deposits we rejected. For us to do this, if privacy is by default, it means we would have to monitor every single Ethereum transfer. And that seems very difficult. And so I hope one day we can scale up to that responsibility, but today it would be very scary.
What about like if like privacy pools are somehow baked into DeFi in a way where it's like, yes, they're still running ASP checks on like who is, which transactions are legit or not, but like it's sort of on by default.
He knows the terminology. ASP is association set provider. It's like the guardian. It's our role of of monitoring and approving. Carry on.
Yeah, good, cool. But like the idea that sort of like it's on by default, but on running through one of there's those anonymity set providers where it's like not, so it sort of is default, but not purely default. Like you've still got to opt in, but it's like sort of baked into a lot of DeFi in a way that means it is normally baked in.
Yeah, I think that would be a great idea, so that people can opt into the privacy set, and then that way we can monitor those transactions and support teams that are trying to keep illicit money out.
The other answer I thought was interesting is like thinking about like voting inside of a lot of these DAOs. I mean, maybe you think half the industry seems to think that DAOs are completely fucked, and I would disagree. But thinking about like private voting inside of DAOs, and a lot of people have been really interested about private voting. I think like similar to the should it be all the time or some of the time? It should be some of the time, right? I feel very strongly that if you made a DAO where 100% of the voting was private, you would actually lead to more worse outcomes. Now, some of the votes maybe should be, right? It would save the political clusterfuck that is in a lot of these DAOs. But I don't think it should be, you should be able to opt into that around certain proposals or certain structures that you're actually. Is it? I don't. Stop playing with it with me. Yeah, so I think opt in. I would agree. Like it's not by default; it's opt in.
Okay, and I'd like to apologize for any younger audience members for the explicit language on this panel today so far. So let's talk about encryption technologies. Where is more of a mean question. Where are ZK proofs already good enough for mainstream apps? And where do the proving times, the cost, and the UX break the experience?
So most consumer hardware can handle generating and verifying proofs, phones and laptops. So like on privacy pools, it takes a couple seconds to generate a proof and verify it. On weaker devices, it's going to take longer, possibly on the order of several minutes. And so there's still room to optimize in that regard. The bigger challenge is around synchronizing previous state, because if you have a privacy system, well, you don't know how much money you have because you know how much money was sent to you because it was sent to you in private. And so It's all encrypted.
Wait. You're saying the person who received the money doesn't know how much they received?
In order to determine how much money you received, you have to attempt to decrypt every single transaction. And so you see all of the transactions and you're like, all right, let me decrypt this. Was this a payment for me? No. The next one, was this a payment for me? No. Or, oh, this was a payment for me. Okay, now I'm going to add that to my balance, and so forth. And so there hasn't been too much work on figuring out how to scale these systems in order to allow for people for there to be a large amount of transaction volume, but still have the ability for users to quickly synchronize their state and their balances so that they know how much they've been paid.
So I wonder if you have an opinion on this, James. FHE versus ZK. To what extent do you think they're complementary, and to what extent do you think they're competitive?
I think that is above my pay grade, and I would fully delegate to the remaining of the room. I think, like, from my perspective, I don't really care. You know, like, I think they're both fucking excellent technologies, and both camps that are building on both sides are great. And like, I want that to be more usable on top of Ethereum and what a EVM magic. And I think that would be my answer to that question.
I was mainly hoping that you would say the word fuck at least one time.
Nice.
So you
Well,
did. Thank you.
That I can do.
All right. I mean, what did Tornado Cash and privacy pools teach us about designing both user privacy and controls over illicit finance?
Everything we've learned the hard way. So it taught us that probably the most important lesson that I've had to learn is that despite how much I might wish this to be the case, that financial privacy is just like encryption, I don't think that's true. And so we like to make the case, we're like, okay, it's just like encryption, but if I'm encrypting communications, I don't need anyone else to encrypt communications for me to get the value of encrypting my communications and get the benefit of having secrets with somebody else. But if I'm using a financial privacy protocol and I'm the only one using the financial privacy protocol, it is very obvious who I am. And so the privacy that I get when I use a financial privacy protocol is derived from all of the other users also using it. And so the conclusion that I've come to is that the quality of my anonymity set matters as much, if not more, so than the quantity of my anonymity set, all of the other users. I don't, for example, want to be in the anonymity set that includes North Korean hackers or the Islamic Republic of Iran, for example. And in order for me to not be in the same anonymity set as them, I have to, and this is what we call the paradox of privacy for the good guys, is that it requires surveillance. Because now I need to figure out who the good guys are. And so in our system, we use know your transaction monitoring. And so we monitor the flows. And so if we see, and to some degree, like, I don't care what ID you show me if you hacked a DeFi protocol, right? So we don't do the KYC part, but we still care a lot about where the money's coming from. And so if we can identify that it came from a source that is illegitimate or illicit, we'll reject it. And that way, all of the other users can dissociate from those illicit funds.
Is it like that? Can that surveil, like, right now the surveillance of those transactions is done by block analysis and a bunch of other companies that are like very good at sort of understanding what
chain analysis.
Chain analysis, yeah. Block analysis, better. Chain analysis. And like, is there a version of the world in which that surveillance can be done by a wider group and it can be done by us?
If you have the computational resources to monitor the whole chain and all transactions and determine the source of funds of all of the deposits and express your own opinions about which of those are within your risk thresholds, you are more than welcome to use your own list.
But like, does that make, because that makes the surveillance better, right? Because like, hearing you describe that, and I'm sort of like, like, that's fucked, but I agree. And is there not? Yeah, I'm hopeful that we whatever we is, can like get those resources and get that computation and sort of be able to do that in a way that isn't like one single central authority or a couple of central authorities, and is instead sort of like the surveillance DAO.
Sure. Also called Five Eyes. But the point he's making is a good one. In the privacy pools paper that Vitalik and I wrote originally, we had a more free-for-all model where users would, when they withdraw, provide the list that they wanted to prove against. And we originally designed privacy pools as a product to work that way. And then we went to our lawyers and we said, hey, what do you think? And they said, so what you're telling us is that for everyone that you reject, it is also essentially a Tornado Cash equivalent on your same smart contract. And we said, yes. And they said, can you make it not do that? And we said, yes. And so the 0 to 1 of this works in this way where Oxbow is the sort of centralized guardian of the pool. Of course, you're always welcome to fork it, make your own, express your own opinions about which deposits you accept. But I'm optimistic for us getting to the like 1 to n model where you can have a pool that has multiple guardians and different basically service providers that you can pay a small fee to verify you, and then they can express an opinion about your deposit being approved, and then when you withdraw you can prove that you are on one of those lists, but not necessarily it being tied to a single one forever. And in theory you could provide your own list.
James, this is my panel.
Okay, sorry.
So let's talk about use cases. So James, which use case will break out first and why? Consumer payments, social, gaming, institutional DeFi, RWAs, identity.
Which one will break out in a privacy sense?
Yes, privacy.
Those?
Yeah.
I mean, I don't think it'll be gaming. I think first we can find a game that works, and then we can make a private game that works. I think probably some of the institutional shit, will be actually like, I mean, even like my follow-up question to your panel was going to be, about like the sort of liquidity inside of privacy pools right now. And even like compared to the early days of Tornado Cash, maybe before it was being mass used by terrorists, like that comparison of the liquidity is like really interesting to examine. And so maybe a similar question, but like I think institutions are going to come in and be like, no, I don't want to have. Maybe some of them want to put all of their ETF holdings into a .eth address, right? Like and publicly display it, and that is good. But also the idea that if you don't want to do that, you can do it, and the way you acquire your ETH from Coinbase institutional, and then they send it to your deposit address, and then someone's watching like the EF transactions, right? And like the Ethereum Foundation sells some ETH, and everyone freaks the fuck out. Like if JP Morgan sells some ETH, maybe they don't want to disclose it, right? And so I would imagine like some of the big liquidity that goes into the privacy space on top of Ethereum is more from institutions first, and maybe like DeFi integrations that allow like my withdrawal address from my Aave is my privacy pool, is using privacy pools to withdraw to my own address.
What do you guys make of Cantor Network's approach to privacy? Like my own 2 cents is that it's private in the way that like your bank is private, like it is this the information superhighway of the blockchain ecosystem, or like consortium chains 2.0, or is this something, how do you view this?
What's Canto Network?
Yes.
Canton Network.
What's Canton Network?
Yeah. Well, then you will have no opinion. You will have no opinion to give on this subject.
I'm gonna imagine that it's like some sort of like threshold decryption thing, right?
No, it's not.
No?
It's not.
What?
It's basically like a consortium chain, pseudo blockchain, institutional thing that's getting a lot of buzz right now in the institutional space, and that it has successfully branded itself as like a privacy solution, but like its privacy is more kind of like because it's centralized and they're the centralized parties that can see everything don't tell the outside world.
I'm always skeptical of these things. For example, like what James was saying at the beginning is that before we had things like Tornado, we would run money through centralized exchanges like everyone else. But that isn't actually great privacy. When you use things that are, zero knowledge proof based, they can't actually leak any information about you. Whereas, like, I have friends who have parents whose data was leaked by Coinbase, and that's because, like, your information security at any exchange is as good as their weakest support engineer. If somebody gives their support engineer $1,000, they will give them all of your information, and that's not great. And then what people do is they use that data, they call people, and they try to convince them that they're a representative of the exchange, because they say, hey, look, we know your transaction info, your account has been compromised, you need to withdraw all of your funds immediately to X. And they get their wallets drained, and they get their wallets drained by the custodians that are supposed to be protecting them. And so I don't think that creating centralized data honeypots that will inevitably be exposed is a great idea for the long term.
Agree.
Agree as well. Okay, so let me ask you each a question. What is the privacy hill that you would die on? You go first, James.
The privacy hill I would die on is that, if similar to the panel discussion earlier, if blockchains and like the corpo chains, and maybe that this is an example of it, the last example, like if we're moving towards JP Morgan chain and Stripe chain and all of these sort of centrally controlled chains, decentralization is important, and privacy is an equally important thing as an outcome of decentralization. If we never have privacy and we just have decentralization, then actually, I mean, even like all the RPC stuff is another great example, right? Like someone just has your IP address, and MetaMask, who just has a big list, I mean, hopefully not, has a big list of all the IP addresses and where you've transacted from. And it's like, well, you might say that you lost your address in a boating accident, but actually, like, I can see that you're in New Zealand transferring from the ledger. And so I think that, like, whether the full stack of privacy, whether it be sort of like the actual hardware or the sort of networking, or where your ETH is moving and where it is going, without Ethereum having these types of technologies built on top of them, then what we're actually building is a lot closer to a corpo chain than we give it credit for.
I'm a really big fan of private voting things. I hope to, before I die, live in a country that has at least one ZK-based election. That would be amazing. There has been a great amount of progress on this. About 2 years ago, I commissioned a report from Moloch DAO called The State of Private Voting, and I paid a guy to basically go push every button on every private voting app and tell me where they were flawed. And some of them is like, oh, well, the tallier can see all of the votes, or the votes are decrypted at the end, or people can see that you voted, but not how you voted, and it turns out, I also wanted to answer your ZK FHE question because it's relevant here, but it turns out that ZK by itself is not enough for any sort of practical election voting system, because another way that you can leak information is, yes, I have participated in my anonymous vote, that you tally immediately, and then you can see that the tally went up by 1 vote, and that also leaks. And so you need ways of recording all of the data privately and then computing on it privately until you get the output. And so that requires the combination of both ZK and FHE, and the tech is basically ready, and I'm very excited about it, and I think it's dope. And there's people who are doing great work on this kind of stuff, Vakdoni, and I'm a big fan of the ZK Passport initiatives. One is called ZK Passport, another one is built by Rarimo called Freedom Tool. I had the privilege of going to Kiev for ETH Kiev last year, and finding out that these Ukrainians built a really funny anonymous voting system to troll the Russian elections by just making a fair election. And it got like some tens of thousands of participants, and some opposition leader endorsed it, and it was pretty cool. And then we realized that the same,
and it verified your Russian passport.
Yeah,
right?
yeah. So let me explain just a bit how this works. It verifies that you have a valid Russian passport signed by the Russian passport issuing authority, does not reveal any information about your passport, you're over the voting age, it's not expired, all those checks. And then you can register to vote, and then you can vote. We realized that the same system worked for the out-of-the-box matched the Islamic Republic of Iran passports, and so we decided to make our own. We basically forked it, translated it all to Persian, and launched our own thing called Iranians.vote to have a vote of no confidence in the Islamic Republic election. We stayed an extra week in Kiev and did this, and it was pretty funny. And so yeah, I'm bullish on fair voting systems that will, just by virtue of being fair, piss off authoritarian regimes.
Okay. Thank you. Thank you, everyone, for listening. We appreciate you.
Thank you, thank you. Next up, we have Hailey presenting on ZKYC, the end game.
Right, people can hear me. Yes. I'm gonna do a presentation how we all know ZK is the end game, and I'm gonna talk about how ZKYC is the end game. I'm gonna take a bit of a step back, go back on why TradFi is certainly moving on chain, then do a short detour on privacy. I'm gonna explain Zcash, might give some color to the panel before, and then I'm gonna shield my bags. So I'm Lancelot. I'm co-founder and CTO of Hailey, and I'm going to be your flight assistant today. So look at his graph. And I hope at least one person has the Nickelback reference to this. This is the total real-world asset value as per the Andreessen Horowitz State of Crypto 2025 report. This number is going up, and it's going up exponentially. And the question is, why is this number going up? And my answer is another question, and that other question is, did you know that TradFi infra actually kind of sucks? We always complain about blockchain, but we're actually doing really well because in TradFi they're partying like it's 1977. This is the year Swift launched. Famously, banks are still using COBOL, which predates 1977. And in TradFi, it's actually decentralized. Everybody has their own ledger, everybody has their own state, everybody knows only the right thing. And there's bridges everywhere, effectively. And it's a lot of fun to reconcile ledgers. It is not a lot of fun to reconcile ledgers. And this is why it literally takes days to settle transactions in the TradFi world. If I'm selling you, a stock today, you're only going to be the legal owner of it in 2 days because for legal reasons, because the auditor needs to make sure that things are happening, transparently, they have to take 48 hours to do this. So yeah, TradFi infra, not great. This is how many layers there are if you want to move around a share of a security. Not amazing. As you can imagine, everybody takes fees in this graph. That's also not amazing. Yeah, blockchain fixes this. We always say that, but it's true. If you look at stablecoins, they're 100x improvements over traditional payment rails. Settlements nearly instant, even on Ethereum, because if you compare, 5 minutes to 2 days, it's basically automated. Cost is way cheaper, especially for international wires. I'm not going to go through the whole list. This is a McKinsey report, but stablecoins are just great. And blockchain in general is just much better TradFi infra than the existing TradFi infra. We're great at consensus. Blockchains are great at transactions. Blockchains are great at transparency and auditability. Of course, not everyone is currently on chain, and you might be wondering why. Well, there's three big reasons. The first is poor performance. It is true blockchains have poor performance. MasterCard, Visa, they're doing about 15,000 transactions per second, which is not like a huge number, but it's still like way more than what even Ethereum with all the LTs is doing right now. There's no privacy, or if you have privacy, unless you're like a fancy user like the previous panel guys, you're not going to have compliance. I like Zcash. The regulator does not like Zcash. So there's some companies that I'm not going to name because they've been named in the previous panel that are claiming to fix these issues. They say they're performant, they say they're compliant, they say they're private. And it's true, they're performant because they're centralized. They're compliant because they're corporate chains, and they're private, but I wouldn't bet my life on the CIA not knowing what goes on there. So we kind of have to make a choice in crypto. You can go on the right, and it's basically same thing as your bank, but in the cloud. And Coinbase is asking you for KYC every week. And sometimes you still get debanked, you know, because, I don't know, you didn't send the right document for some reason. Or you can go on the left. And we can try to build a permissionless self-custodial system where you can prove that your funds are AML compliant from like the comfort of your couch without revealing where that very comfortable couch actually is. That sounds much better. I think you'll agree with me. And the good news is that we have the technology to do this, but to do this, we need to take a hard right. We need to leave the road to surveillance states and take a sidetrack of elliptic curves, zero knowledge. ZK gives us most of the tools we need. I guess there's like a little bit of FHE that needs to be added on top for this. The first thing ZK gives us is high performance. This was proven years back with StarkX and DYDX, and we're relearning this lesson with Lighter. The chart on the right is L2-bit Ethereum transactions on the ecosystem. It's recently spiked because of Lighter, who's doing a very efficient app chain using ZK. And you know, we got real-time if proving if you have a lot of GPUs, the performance is there, and we can do really cool things with it. The reason it works is because ZK allows you to have really low state on chain, really high throughput, and it's also super flexible. And this is one of the good things. I like to use a metaphor of an iceberg. Essentially, if you're doing a smart contract on Ethereum, you have to put the whole iceberg of state on Ethereum. If you're using ZK, all you need to store on Ethereum is the tip of the iceberg, the state commitment, you know, maybe a few metadata, but it's much, much less information. And it's like 95% more efficient. The second thing ZK gives you is privacy. So of course, like we all know, not all ZK systems give you that, but some of them do. You can do transparent stuff on Ethereum, but you can't really do anonymous, confidential, or private transactions on Ethereum unless you're going through stuff that use ZK. This is great. And so I wanted to evangelize just a little bit about how this works, actually, because I don't think people know, and it's actually quite simple. So let's do a short detour on how Tornado Cash, Zcash, and other like ZK mixers actually work. The basic idea is that you have two boxes, and you have notes in those boxes. On the left, you have the box of notes, and on the right, you have the box of nullifiers. Nullifiers are just a fancy term to say that each note has one matching nullifier, exactly one. This is deterministic, but you cannot know which note has which nullifier. So this is critical because otherwise the whole system wouldn't work. So there is exactly one nullifier for each note, and you can't know which. The idea is that only the note holder can read the contents of their UTXO. So this is why there's the problem that Amin was talking about earlier, that you need to look at every transaction if you want to know when people send you money, because only by attempting to decrypt every note can you know which notes you potentially own. And so when you spend money on a system like Tornado Cash or Zcash or things like that, what you're actually trying to do is two things. You're proving that you own a note that is actually in the box of notes, and that like the money exists, essentially. The second thing that you do is that you're proving that its nullifier has never been revealed. And that accounts for the double spend problem. So if you can make ZK proofs of these two things, then you have money that can legally, like in the conceptual sense, be spent. The way it works is basically that, well, when you spend a node, you just reveal the matching nullifier. So now that node has been spent. If you were trying to spend it again, you would have to reveal the same nullifier, which wouldn't work because it's already in the nullifier box. And when you spend the node, maybe you mint new nodes, but you never change any of the existing nodes. And so what this does is that from the outside, it's impossible to know which of the nodes on the left was actually used to process a payment, to withdraw money, to do something like that. And like this is the essence of the anonymity set idea. The more nodes there are that are not used, the more anonymous you are, because the more confounding it is which of the nodes you've been using. And the reason why people do analytics and try to crack this stuff is that if you have 1,000 nodes, but you have 1999 of them that are currently already used, there's only one node left, and if you can figure out which one that is, you've cracked the privacy of the setup. So that was a quick primer on ZK mixers. Not actually that complicated of a concept, really cool technology. I'm not going over how you do like compliance on this, but you can prove which nodes are clean and which nodes aren't. And the third thing that ZK gives us critically is better compliance. And the way that works is that ZK allows you to do really fancy discrimination, also known as selective disclosure, while preserving your privacy as much as possible. You can do proof of passports. I'm a resident of a country. You can prove where you live. You can prove that your funds, come from some legitimate source, maybe like your company payroll. You can prove you're not sanctioned under OFAC lists, or you're not a Russian asset or something like that. You can prove you're over 18, which is sometimes useful when you're browsing the internet in private mode. And this is all given to you for free by ZK. Well, not for free, you have to code it, but and the interesting thing here is that identity documents, for example, are signed by governments. These signatures are public, and you can extract a lot of information privately from this. So if you have a French passport, you can prove you're a French citizen, you can prove your age, you can prove you live somewhere without actually revealing who you are, and potentially, not leaving a trace on chain that can be breadcrumbed to recover your identity. This was used recently, for example, to great success in the Aztec sale. I think that's not quite public yet, to be honest. I think it's just only like early adopters. You might get to try this. They're using ZK Passport to prove that you're not like a UK citizen, which is kind of ironic because Aztec is a UK team. And they're actually like extending that as well to a proof that you're like the actual human in your passport photo. They're doing like cosine similarity using ZK and like the secure enclave in your phone to prove that you're actually the person you claim to be. So it's like really strong proof that you are who you claim to be. And they're using that for the compliance part of their ICO. So the tech is here. We kind of just need to put it all together. We've got privacy, we've got performance, and we've got compliance. And so the question is, who's going to be the hero to unite this Triforce? And so this is where I shield my bags. I'm going to say that Highly unites the three pieces of this Triforce. So Highly is a ZK blockchain. We're doing data availability, sequencing, and we're doing settlement via ZK proofs. We have native ZK verification, which is much faster and supports a whole bunch of ZK VMs. We have Noir, Ligiero, everything that allows you to have privacy. We have a modern high throughput consensus system, which allows you to have like speed, high bandwidth, low latency. And we're going to be building the tools to do permissionless KYC as much as possible and enable compliance on chain. We've been quite busy lately. If you go on our GitHub, most of our code is open source. We've built, so first in September with the Kakarot team that know at Zama, we did a client-side proving benchmark on Kairos 2 called FibRace. Then we did Cash, which is a French wordplay that I don't actually know how to explain, which was about implementing this anonymity mixer using ZK partly in Noir for the privacy and partly in Rust using SP1 for efficiency. And we are currently fleshing out like the code to something called High Liquid, for now, which is essentially like kind of the same design as Lighter. It's an order book written in Rust, proven by SP1. You can swap out the zkVM pretty easily. And we're going to release that code open source next week, kind of like a demonstration purpose of what this technology can achieve. So our belief at Highly is that finance will move on chain, not because of their goodwill, but because it's actually way more efficient, it's way cheaper, and it just makes sense from an auditability perspective. AML will be privacy preserving and permissionless with zKYC instead of being like the privacy nightmare that it is today, and also like the massive hassle both for companies and for people. And now is not the end of history for blockchain. This is a link to our Telegram. We're also on Twitter. You can check out our website. And if you have further questions, we'll be at several more events with ZK in the name in the coming days. And I think I'm going to stick around for a little bit here. Thank you for listening. This was Hyden.
Thank you to Lancelot and Hailey. Next up, we have Turnkey.
Get a thing for a second. Yeah. Hey. All right, we're in business. All right, thank you everyone for coming. My name is Michael Lunn. I'm here to talk a little bit about Turnkey, how we protect key infrastructure with secure enclave TEs. Not as fun as some of the other cryptographic methods we've talked about today, but sometimes simple is better when you're talking about security. So just a little bit about myself. Been thinking about crypto security and key management for a while. I spent 4 years at Open Zeppelin, working a lot on smart contract security audits, as well as advising protocols on how they'd implement security, working with big DAOs and protocols like Compound, ZK Sync, Arbitrum. Recently spent a brief period at Blockade for about 6 months, but did learn a lot about integrating with lots of wallets, how they do key management around transaction security, blind signing attacks, and things like that. And then a few months ago, joined Turnkey to primarily work on building core wallet infrastructure with our providers, building embedded wallets or back office automation. So working with customers like Anchorage on like the crypto banking institutional side, but also working with a lot of kind of consumer apps like Axiom, Polymarket, et cetera. So the agenda here is I'm just going to kind of talk about wallets very broadly. I'm going to be a little bit technical, but I also kind of want to give us perspective of like where we've come to today with wallets and how users are trying to use them today, and then like how we're trying to solve some of the core challenges around wallet infrastructure with Turnkey's approach to secure enclaves, and then talk a little bit about how devs are using Turnkey today. Might even also talk a little bit about how we're expanding our use of secure enclaves into other use cases beyond secure key management. But yeah, just to level set, I think most people are aware of this, but you know, he who controls the keys controls crypto. This has been the ongoing challenge that we've had in the cryptocurrency space since it's essentially been adopted in early 2010. And in 2025, 80% of crypto thefts have come from infra attacks, which have either been the theft of the private key itself or something around the signing of the transactions using those keys. Now, obviously, of the 1.68 billion, can y'all guess where the vast majority of the money came from? Is probably Bybit. But even then, like this is still a trend we've seen in the past years where like even though there have been like large upcropping of sophisticated smart contract attacks and cryptographic attacks, it's usually down to key management. That's usually either the key management of like how the key is secured or how it's used to sign things is usually the weakest attack vector that threat actors go after. And it continues to be our biggest concern, especially as we now start to broaden and get into broader retail and institutional use case adoption. So some of the early examples of this, well, Mt. Gox was the great example of how poorly you can do key management. Does anyone know how many times Mt. Gox was hacked? Yeah, I mean, like, I think they lost track too. Like, to the extent that, like, this wasn't just one hack. It was like happening over the series of like an entire year where, oops, we got hacked again. Let's patch that part of the server. Oh, we got hacked again. We just patched that part of the server because they just consistently used hot wallet keys that were sitting in the server. They never implemented a core storage approach. Didn't even try to mitigate those risks. Their idea of mitigating it was to try to trade on their own exchange and make the money back, and then they somehow lost money in a bull market. God knows how. So that was an early example of just how poorly key management can be done by a custodian. And then even later on, we had also had Bitstamp that lost a lot of funds to operational key exposure. So what we learned is, okay, if you centralize your trust into a single custodian, you have a single point of failure, you can lose a lot of money. Obviously today, Coinbase and other custodians are much more sophisticated. We haven't seen these sorts of attacks happen again, but there's still a risk factor there that you have to consider. So of course, everyone's like the whole, not your keys, not your crypto thing became very prevalent after this. So people were like, oh, why don't you just have self-hosted wallets? Have all your users set up their own wallets with their own private keys and their own backups, and then they'll be protected. They won't have to worry about the fact that there's a single point of failure. Well, the problem is that's really stressful for the vast majority of users that are not sophisticated, do not have basic OPSEC skills. So while you have spread out the attack surface so that you have to go after individual users, we now have an entire class of threat actors, wallet drainers, and other hackers that are now targeting individual users with more of a spray and pray approach, just like spam, to try to get people to either accidentally reveal their seed phrase. You'll have websites that literally pop up that say, in order to sign this transaction, give me your seed phrase. And some people do it. Maybe only 1% of people, but like every Nigerian prince scam, you just need a couple for it to be profitable. And then, of course, the way that people use these backups, they're usually like, oh, I'm just going to take a screenshot of that, or I'm going to pop it into my Google Drive. Or I'm going to do other things that really, if you're managing hundreds, thousands, or millions even of dollars, that's not a good attack vector. In reality, most people should be going out of their way to put it only on paper and then putting it in a safe and then making sure that safe is secure, because at the end of the day, that's a unencrypted version of your entire wallet. And a lot of people might not have the sophistication to do that. And then in general, even in the best case, even if you have a user that understands these risks, manages them well, it's a friction. I remember when I'm asked to set up a wallet going to like a conference, it's like, oh, we have a wallet for buying food at the food truck or something like that. Well, great, now I have to set up a wallet just for this. And hopefully I've done this. I've definitely just screenshotted my seed phrase, put it back in, and then just like, all right, I'm done. I'm just never going to use this wallet for anything more than $5. But in reality, there's a big onboarding friction, and the vast majority of users out there that are non-crypto are not going to go through these steps, much less appreciate the risks that they might pose, even if they went through them all. Okay, so we need something better than this. There are other ways to at least spread out the attack surface and make it so that you don't have a single point of failure. And these are both multi-sigs and MPCs. And they both have their place. They're both valuable. MPC also has a lot of broader use cases that are being talked about in the case of privacy preservation and other things. With multi-sigs, I would say generally going to be more secure, but you are introducing friction intentionally. You're going to have multiple people sign off with their own key. It's not going to be multi-chain by default. It's not going to be super user-friendly. So these are good in cases where maybe you're managing millions of dollars for a fund, or you're managing it for a treasury, and you're willing to put in a lot of operational overhead to approve transactions. But ideally, this is not something that you're doing regularly. This is not going to be something that's good for a high volume or consumer-friendly use case. You're probably also not going to want to be using this for things that, or rather, you're not going to want to have people on these multi-sigs that don't know how to analyze what they're signing. So obviously, blind signing attacks like Bybit are still feasible here if people are not validating the transaction. And then MPC is also attempting to do this, but shards an individual key using MPC cryptography. But it's opaque and it has complex setup. You have increased signing latency. So if you have a consumer application or you have a trading use case that has latency sensitivities, you're going to take a big hit to that as well. Because you're going to have latency between all the different nodes that are doing the signing. If you don't have latency, then that means you're probably keeping them very close together, i.e. another single point of failure. And there are also still zero-day exploits that are coming out for MPC. In 2023, Bitforge came out and impacted many different implementations of MPC, and are both susceptible to blind signing if you're not independently verifying what you're signing. If everyone in these signing ceremonies, whether they're separate keys or having shards of the same key, if they're all blindly signing the same thing and they're not doing independent validation, you haven't really spread out your attack surface. Usually someone is going to initiate transactions and everyone else is going to say, I assume whoever initiated that is trusted, and not really validate the details very deeply. So this is still an ongoing issue. You can improve your operational security to mitigate this if you are a sophisticated actor, but for consumers or for even institutions that are not like very crypto aware, this does not cut it. So we need something better. And that's ultimately the wallet problem we have. We have trade-offs. Custodial solutions are going to be a single point of failure. There's going to be regulatory overhead to that because you have to be a qualified custodian, or you're going to have to comply with some regulatory requirements. If you're self-hosted, it's a fragile, stressful UX. You're going to also have security risks of being, directly attacked. And with multi-sig and PC, you're introducing complexity. It's going to have certain limitations, and it's still going to have attack vectors. These all are going to have different attack vectors that you're going to worry about. And everything does. But what we think is a good solution to solving the majority of use cases that we see for retail and for back office automation and for the ways that people actually initiate and sign transactions on a daily basis is using secure enclaves with the way that Turnkey has implemented it. You've probably heard about them, or TEEs, where essentially you have hardware that is providing guarantees around how the software that is running inside of the hardware device is going to be operated. So you can attest to the fact that certain software is running in it and that no one else has access to to get into the access. So it's isolated, it's tamper resistant, it's attestable. You can prove what's running inside these boxes. For us at Turnkey, we specifically use AWS Nitro, which is the AWS offering for TEEs. And the idea is that now, as operators, we cannot extract anything from these TEEs. None of our customers who build on top of us can extract anything from these TEEs. Really, the only way that can be done is if someone literally cracked into the AWS data center, had sophisticated technology, and was trying to extract it directly from the servers using side channel attacks, which frankly is always going to be an attack vector for any piece of hardware you ever have. So generally, you get pretty good security guarantees. If you're using a trusted operator who's running that node, or essentially running that software, everything else can essentially be considered secure in terms of like who builds on top of it, including Turnkey ourselves. So TEs are generally pretty available. Lots of people have built use cases with TEs, so it's not like this is not new technology. But what Turnkey does with TEs, I think, is very specifically unique. And that's the way that we embed not just the key signing and key generation, which would obviously be how like secure hardware security modules work, like on your phones and on other devices, but we embed everything related to the transaction lifecycle that we're a part of into the TEE. So whenever you're going to Turnkey and you're initiating a transaction signing request, it's not just taking that request and signing it and avoiding key exposure. It's actually looking at, okay, who authorized the request? We have authenticators. We have API keys, P256 keys that are essentially using asymmetric cryptography. We have pass keys that are following a similar format. We also have email, OAuth, SMS, things that can integrate with other third-party providers that can essentially provide different validation methods. And all of these are going to be validated inside the TEE. So the first thing we're going to do is we're going to say, is this user with that authenticator authorized to sign this transaction? And on top of that, we can also parse the transaction, and we can look at the transaction details and add on custom policies. So we could say, okay, for these types of transactions, you need to have multiple approval steps. Multiple people have to sign off on this. Or you could have a system where it says, hey, I'm going to delegate access to an API backend to like initiate trades on a user behalf, but they can only do this action and only this action, and the policy engine is going to have to validate that. All of that lives inside the TEE, so you actually have a large level of trust, not around the ability to sign the transaction, but how that transaction is authorized in the first place. So at the end of the day, we can actually claim truthfully to regulators as well as to security professionals that this is a self-custodial setup, because we can't extract key material. Our customers that build this for their users can't extract key material. Only the end user with the authenticator, which is going to be a cryptographic key through a pass key or an API key or otherwise, can actually initiate and authorize transactions. But you still get the advantage of horizontally scalable infrastructure where this is all running in Kubernetes. It can horizontally scale. You can meet 1,000 transactions per second use cases without having to compromise the security model. So that's why we like this a lot, and that's why we've had a lot of customers that also like working with us quite a bit. So specifically going through the advantages again, it's verifiable. We can remotely attest to what is running in the enclave logic. We also have reproducibility around everything that we build and submit, so anyone can independently, reproducibly build and verify the logic running inside of our enclaves. That's what we do directly with some customers, and we're now open sourcing more and more of that to allow customers to do that on their own for us, or rather, on their own to validate what we're doing. We have security. Everything is end-to-end encrypted and authenticated. So even if our backend was compromised, all the key material is safe. No one can initiate transactions that they're not allowed to. Really, the only thing that could happen is potentially like limited availability issues, and then from there, that can be easily resolved. So the key material is never going to be exposed. And then it's fast and scalable because this is not really outside of the use of the TE. This is actually not that complex. So you can scale it horizontally. You can have sub 100 millisecond signing latency, which is super good for users. Anything above 200 milliseconds, you start to actually have users drop off. Once you get up to a second, literally half of your users are going to quit because they're tired of waiting. That's like data that we've collected from Google on mobile application UX. And then the UX can be very familiar. Users don't, when they're setting up a crypto wallet, they don't have to think about private keys. They're using passkeys, they're using email, they're using OAuth. They can have multiple recovery methods. So they could, use a passkey for normal signing, but they could use an email plus OTP, or email OTP plus maybe like 2FA or authenticator Authy style 2FA to recover. So you can build very flexible recovery methods that are basically as secure as like a Google account would be today, but it's going to be very familiar to the user as opposed to, backing up seed phrases and dealing with key material directly. And, at the end of the day, if you want users to be able to back up your private key, you can also do that too. But the idea is that shouldn't have to be a requirement because we just know that the average user will not do it, or if they do it, or you force them to do it, they're probably not going to do it securely. That's what we've learned after 10 years in this industry. So why does this matter? Users are not going to have seed phrase anxiety. They're going to have recoverable wallets, and it's still going to be non-custodial. And then builders have a super flexible API. The way we built it is, okay, you can basically have a secure custodial or non-custodial setup. So some of our people or some of our customers, for example, are fully custodial. They're moving money for their own internal back office purposes, but they can have a robust hierarchical security model where they have the principle of least privilege for all the API keys. So if developer goes rogue, they don't have the access to do anything that can be harmful, as well as just the general security model for the whole infrastructure. And they can manage it centrally in a very secure way. But if you're non-custodial, then you can make a non-custodial app that can have wide user adoption while introducing a lot of friction. And then in general for industry, we think mainstream adoption, people are going to gravitate toward things that have high performance. So ideally, we want to build something that's going to be able to match that performance, but still have a lot of security guarantees that, again, will not have to be reduced or compromised as you want to scale it. And so generally speaking, we think about this as Lego kits. Our system is built with very low level APIs. So a lot of our developers come in. All it does, it's literally just cryptographic. You don't even need to have chain support. If you use SEP 256 or Edwards curve, we support you out of the box. It doesn't matter what your blockchain is. And then from there, you can start putting legal pieces together, figure out what your policy system is, your custodial setup, what recovery methods you want, what authenticators you want. Whatever it is, you can cobble it together and build a very robust application. And just now, this week, we're coming out with verifiable compute, which is basically going to be our offering to allow you to write your own TE applications in Rust or whatever language you want. And you can plug that into the same system and you're basically going to use the same infrastructure we built for key management for any use case you want. For example, Anchorage is now using us for transaction parsing. So they can independently parse a transaction, tell the user, and attest to the fact that was parsed using the logic that they had open sourced and anyone can validate. And then you can know that that's what you're then signing on your client device. So a couple examples. One is Infinex. So they're a cross-chain DeFi portal. They've amassed over 500 million in TVL, and this is all users using a passkey to trade across multiple blockchains. So the sign-up experience literally takes the 30 seconds that you're watching here on the screen, and then they're suddenly live. They have a wallet that can access multiple different blockchains, and it's all secured with a passkey on the client side. Another example is delegated access for AI agents, which I think is a fun one that we'll see more of. So for example, when you have an AI agent, that AI agent is doing trading. It is going to be initiating things on your behalf. And of course, sometimes AI hallucinates or does other weird things. So having scoped policies where you're like, okay, I'm going to delegate access to this thing for it to be able to do certain trades on my behalf, but it can't, for example, withdraw money, or it can't do other things that could potentially cause a large loss of funds, or a hacker could potentially manipulate. There might still be some ways for them to initiate damage, but generally speaking, you can scope it to least privilege and keep it very secure without compromising the user experience or the performance of that AI trading bot. So we've seen a lot of customers like Spectral use us for this. So I'll end it there. I don't know if we have time for questions, but generally speaking, this is something that I've only been at the company for 3 months, but I'm very excited about our architecture. Worked with a lot of customers on it, and would love to chat with any of y'all afterwards if you're interested. No one tells me we can't do questions. I'll take questions. All right, question. So side channels are a part of the risks that you're going to run with TEs if you don't have a good security model around the physical hardware. So TEs pretty much cover everything up to the physical hardware, but the physical hardware, you do need to at least have a decent guarantee that whoever's operating that hardware is not going to try to directly access it. And for us, our security model is AWS is some of the most secure, trusted data servers in the world. So we have a strong guarantee from them that they're not going to compromise it by they're not going to burn their entire business model to the ground to compromise RTE specifically. I think the area where a lot of these like recent TE side channel attacks have come up as an issue, which by the way, they haven't seen any that affects AWS directly. It's potentially possible, but they've usually targeted Intel SGX or others. But if you do a permissionless TE network, like Secrets Network or other things where you're like, oh, anyone can run a node with a TE and then it's totally secure, that's a model I would not trust because then, yeah, you don't have guarantees around how it's physically secured. So I think TEs are great if you are willing to take some trust assumptions on the physical layer of how it's hosted. And then the nice thing is if you get that, then everything above that is highly secure and you can build some really strong assumptions on top of that. So and if you're in a case where, let's say you're holding $100 million, you're like, well, maybe I don't want to worry about an AWS operator going rogue or something like that. Use a multi-sig probably, or use something that you're going to take a trade-off on because it's not going to be as performant maybe, but you're willing to have a multi-approval step that's maybe a bit slower in those particular cases. So I see like turnkey TEs as great for the vast majority of use cases we see, but there might be ones where your threat model would lead you in a different direction. Yes, so I talked a little bit about it, but we, like, as of a week or two ago, released turnkey verifiable compute, or turnkey verifiable cloud, which basically is like, okay, you get everything we've talked about, all those security properties we talked about for key management for any application you want to run, where you can essentially, it's basically an off-chain smart contract in the sense that you can deploy the logic, and just like you can look at Etherscan and check that's the code running at that smart contract address, I could do the same for what we run here, except it's private. It's horizontally scalable, and you can run it in any language. We're primarily seeing customers use Rust, but you could run it in other things. So our biggest customer is Anchorage. They're using it for transaction parsing. We're talking to a few other customers right now. We're in beta, so this has just been released, but by January, we expect to have this become more open access. And from there, we're literally going to be the place where you could bring in your Docker container and upload it, and you could have multiple people sign it. We actually have a multi-sign system where you could essentially sign the deployment. And if you have like a quorum of users that are like, developers deploying this, like a deployer address, they can attest to like, we've signed off on this manifest, we're going to deploy it. And then anyone can attest to like, that is the same code running. If you open source the code, they could validate that that is the code running in the enclave, and they could validate the people that signed it, match a certain public key. So you can build a lot of security properties around that. So anything that I think what's going to be interesting is like there's still things I would still build in a smart contract on chain, like money settlement probably. But there's a lot of other use cases like transaction parsing, Oracle aggregation, like running an LLM, running a node actually, you could do inside of a TE in this use case. All right, sweet. Thank you all for your time. And yeah, look forward to speaking all about the week. I'll be around for the next few hours.
Thank you to Turnkey. Next up, we have a ZK panel featuring Horizon, LTV Protocol, Brevis, Forgers, and Verimo.
I think this thing is on, is it? Yeah.
Let's test. One. Testing.
We're almost a karaoke group at this point. Okay, I think I can kick it off. I'm looking for some information here. Fantastic. So thank you everybody for being here. Thank you, gentlemen, for being here as well today. My name is Michiel. I also go online under SMF. I got doxed accidentally a while ago, so you can easily find everything you want about me. I have in the past worked with various privacy organizations from IFT, Logos, to Radical, to Web3 Privacy Now, to now also working with XX Network. I am not the point of attention here. I have these very intelligent people left on me who will very gladly introduce to them. And then we're going through a round of questions of ZK in action. So please, let's follow from the left of me.
Yeah. My name is Andrei Sobol. Right now, I'm a CTO of LTV Protocol. Before LTV Protocol, I worked for Matter Labs. I did research for Thesis Foundation. And actually, I work a little bit as consultant for Horizon. So yeah, I'm know a little bit about ZK, and yeah, and I'm happy to share some knowledge about all of these things.
Hi, I'm Jinda. I'm the co-founder of Brevis. Brevis has one of the fastest ZK VM right now. And on the other side, we apply this high-performance ZK VM into actual production uses. Like just a couple of weeks ago, we distributed 1 billion linear token for them using ZK verified, a tested user reward.
Hello, my name is Olex. I'm a core contributor to Raremo protocol, Freedom Tool, etc. So Raremo is a key identity protocol. So we have like digitized real credentials, real people credentials, and makes them like ZK friendly. Freedom Tools is like an open source protocol for voting with ZK passports. So yeah, basically that's it.
Hi everyone, thanks for having me. I'm Andy Bryant, the Chief of Strategy for Horizon Labs. We're a bit of an OG company, been around since 2017. Originally, the inventors of Zencash, which was a fork of Zcash. And then over the years, we sort of changed into sort of a protocol company. We've got one blockchain, which is a layer one ZK verification specialist chain called ZK Verify. And we also have the Horizon chain, which we've recently migrated to be an app chain on top of Base. And we're just about to launch as a kind of privacy and compliant layer for the Base ecosystem.
Okay, thank you very much. I would assume you all have heard about blockchain, have you? Maybe, yeah.
What is blockchain? I don't know. What is it?
It's fun.fun, right? I heard about. No, but I saw some very exciting news a couple of days ago, and I would like to first give the word to, should I say Dr. Liu or Yunda, or what do you prefer? Fantastic. You recently launched with your company a ZK Market, where you are capable of having a marketplace and somehow matching the two sides of the market with the computation of the ZK proofs. Could you maybe share us a bit more on how this works on both a technical and business level?
Yeah, sure. Thank you. Yeah, I would say right now, everybody enjoy the technical side of it, but honestly, we cannot overlook the pure cost of ZK proving. It is still very not only hardware intensive, but also operation intensive. You need to operate this kind of high performance GPU clusters to deliver the proof in time. But if you look at the whole, I would say, ecosystem, like there are people focusing more on making verify the proof cheaper and easier to access. But what about the actual proving part? It should also, we foresee that as there should be a very vibrant and fair market, right? People who have access to the hardware and have the expertise to run, they can participate. On the other side, we're hoping to see, because there are, based on Brevis' own production partners, the ZK proof use cases actually are very diverse. Right? It's not like a single case fit all. So we do see maybe some provers are excellent in proving like a smaller, low latency proofs, while some others might be better with their infra to prove like large batch, like for example, a 30-day trading volume we have done for all these top DEX projects. So I think that's why the idea is always there, but how do you really make it, I would say, for an efficient marketplace, the bottom line is it has to be fair. And then you need to have an efficient price discovery. Right? So basically both sides will be happy to participate. Yeah, I think there are more technical to avoid making people sleepy, right? There are more technical details in our white paper, but on the high level is with the clever auction design, we figure out, when the ProverNet, Brevis ProverNet actually goes live, very there will be both a vibrant, like active side of the requesters who need the ZK proof, and also on the other side, the provers who join the network. Yeah, thank you.
That's exciting. Thank you for getting there. I hope the marketplace works out. And I'm sure as we all have figured out, sometimes the business aspects of highly technical and complex applications can be quite hard to find. And I would like to ask a question to the group, as in, what are some of the new ZK use cases we're now only discovering and starting to actually potentially find business applications for, and really put those ZK into the reality outside of the theoretical reality? Anybody who feels like taking this one?
Okay, I can start. The application and the potential use cases that are really excited is that, like, because right now we are doing the DeFi protocol, and they really excite the scenario where, for example, you can like put zero knowledge proofs about like average average Oracle price for the full year. You can just prove the inclusion into every block, and you can prove that like slot changes, so you can aggregate the average price, you can aggregate it into the median, you can get the average like borrow rate on Aave, and it's open a lot of doors if you want to automatize some strategy in DeFi world, because right now you cannot just like from this regular Solidity, you cannot just ask the Uniswap like give me average price for the last year. But if you like provide the market when like some user can provide the proofs about like when they pre-calculate the average price, for example, if you dollar, it's open a lot of use cases because you can show it like provably, not like rely on some Oracle. You can just say, okay, this is average price on these particular exchanges, for example, Curve, Uniswap. So just aggregation the data that already exists in the Ethereum or in the different chains like Base, I don't know, Arbitrum, etc., ZK Sync. So it will be really useful, in my opinion.
Do we talk about already launched, or is it like something coming?
I would be very excited to hear about any kind of use cases that are about to be implemented. So not necessarily yet something that people are willing to pay for in a very direct way, something that people are willing to, in a very business trade way, utilize.
It's actually a tough question for me because we already launched all this. Back to the earlier, I do agree. So everything happens on chain. Like I mentioned earlier, Brevis has basically two parts. One is the ZKVM, the other is basically the coprocessor to prove any historical data, including the computation you want over that. Like it could be the average price, it could be TWA. That's exactly what we actually did for Linea. They said we want to reward user based on their holding, based on their interaction with the borrow, like ARV and all the other protocols. And that's how they can, as long as everything, the activity happens on chain, we compute over, say, TWA and all the trading over specific period of time, what's their average like liquidity contribution to the system. But I do want to mention a very interesting, I would say, use case. It's not that huge, but it's actually touched on one of the interesting points for real user adoption because it actually solve a pain point. For Kaito, people might heard of like there's a Yapper board. So basically you connect your social handle. If you have the most followers, you get a high chance, like rank higher, right?
Yeah, it's quite, people like to game the system,
Exactly.
utilize it, and all different kinds of mechanisms. And that exactly brings me back to also Sasha from Rarimo.
Yeah. So that's the use case I want to bring up because we actually work with them already launched for us and also upcoming for all the other projects. Not only you are the loudest account on Twitter, right? You also need to show you have real on-chain transaction to support the protocol, right? Which is exactly what the project team wants. But on the other side, the people have privacy concerns. Right? They do not want Kaito to know the connection between their social and their on-chain address.
It's sometimes very hard to actually prove we are human, right? In that sense.
Yeah.
And then within
so basically the
Rarimo
link-
goes
yeah,
there further in with the, I believe, something
Right.
regarding the CKAI with biometric proofs that you launched over the year. Could you tell us a bit more about that,
That would
Sasha?
be a little bit long term, but right now, what we can do.
I was giving the microphone to Sasha.
Yeah. Like a very interesting point that nobody cares that you are a human. With ZK, without ZK, nobody cares. Because Bitcoin and Ethereum, they are constructed in the way they don't need a proof of humanity to have a Sybil resistance. So they're using like totally different like methods for that. Additionally, yeah, I'm like very connected to the privacy world, and people aren't ready like to pay for privacy as well. But at the same time, that's probably the reason why Freedom Tool right now is totally open sourced projects. So what we have implemented, we just shown an opportunity that you can perform a parallel election, parallel voting system, not like injected in the government, but like parallel history. But you can perform that in the provable way because every person already received this like credential from the government, like I don't know, 10 years ago, 20 years ago, that's signed by the government. It includes all information about yourself. And you can prove that the signature is valid. You can prove that some data is included in your passport. You can prove the nationality. You can prove your age, etc., etc. And with this kind of proof, you can make useful social like actions. You can participate in useful social applications.
Yeah, it's a very fast-moving world, right? Like new technology starts to interact with regulations in that sense. I would be curious as a chief of strategy with Horizon, how do you anticipate the situation and try to play into that to also actually be able to reach the right people? It's sometimes not just building the technology, but also getting people to give them what they want, which is not an easy thing either.
Yeah, I think you'd be surprised actually how many different verticals and use cases, right, we hear about. I mean, there's the obvious stuff that's things to do with like login or ID, KYC, these types of things, selective disclosure. Then there's those things that feel like still a bit far away, like sort of the agent economy and verifiable everything. And then there's this kind of things in the middle, like we're talking to various different verticals in things like defense and supply chain, even like space, gaming, and especially recently at this event, I think that a lot of people are talking about TEEs. Like we're actually working on our own sort of TEE project on the Horizon side, and it seems that while depending on who you ask, like FHE is either kind of ready for prime time or it's still a bit further away. It does seem to be the case that a lot of people are talking about TEEs now because obviously they're much cheaper and faster to execute. You do take on that new trust guarantee, but that can now be solved by ZK. So we're having a lot of interesting conversations with both the proven networks, but also with the TEE attestations as well.
Yeah, you mentioned all these different verticals and these different industries we could play ourselves in, from verification, interoperability. Aren't we sometimes also staying stuck in our existing silos if we don't start playing into those? As we all are here in the the existing blockchain bubble, we're very technical capable people in this room, especially you guys. Not looking to myself here. How do we actually manage to find the balance between becoming specialist but also not getting stuck into an echo chamber? For the group, whoever would like to take to.
So the question is, how do we avoid we're in the bubble?
Not just how to avoid staying in a bubble. Sometimes I believe it's actually not the horrible situation to stay in these bubbles because you get to meet the experts who are working on the same fields. How to find the balance between not staying only in the bubble, but also be able to explore what is outside of the bubble.
Yeah, so I would say put another perspective on this is basically as a society, different people might be good at different expertise, right? And if you ask someone has done all these cryptographic trainings, it's better for them to continue to the contribution to like fast forward the FHE, fast forward the ZK. And I think there are other people responsibility could be to convert a piece of like a academic paper into a working system and to like all these exciting projects try to find the market fit. Yeah, I think that's kind of not a single person job to do it all.
Does anybody, if I would ask the question, what's the first piece of ZK technology my grandmother will use? Even though she might not know that she'll be using, what would you say it is?
My guess would be on the ZK ID side because so intuitive, like ZK TLS is already like not just usable, right? The user experience actually makes sense. And who said the grandma cannot do crypto trading? It's I would say the underlying blockchain already benefit even, especially in countries their own fiat system is not as strong. So I think once they get into this whole blockchain world, all the rest comes naturally.
Talking about this wider world that interacts with this blockchain world we're building today, Andre, how would you argue from from the DeFi perspective, what is the most wanted and actually useful right now to also get implemented in a world outside of purely privacy and encryption?
In my opinion, layer 2s. They're like layer 2s in general. I mean, like, I can say ZK rollups, I can say optimistic rollups because basically it's more or less the same because you in some cases you prove the correctness, in other case you prove the some correct behavior, but like the real implementation on ZK EVM and the rollups, in my opinion, it's a huge dramatic, success for the DeFi because right now you can have separate chains with the same level of I cannot say the same level of security, but comparable level of security as Ethereum layer 1. So in my opinion, this one. And answering to your previous question about how to avoid to stay in a bubble, I personally prefer to stay in a bubble. This is my life strategy, and I totally recommend to everyone to stay inside the bubble because you're building it like 10 years. I built this bubble 10 years. I want to stay here, you know?
The thing about staying in the bubble is you come to events like this and it's awesome because everyone you speak to like knows what ZK is. They know the difference between Gross 16 and like Halo 2 and things. You're like, oh, yeah, people speak my language. And you can fall into a false kind of sense of security that actually the industry is growing, but actually maybe it's just this tiny like focus group is growing. Sometimes I feel like more than other industries, like the onus is on us more to actually kind of to inspire what's possible with ZK to the non-techies, right? Are we going to sit around and just wait for everyone to finally get it and then the use cases appear and the end users appear and then volume explodes? Or are we going to actually help evangelize the technology by maybe developing our own use cases and pilots just to capture the imagination of, bigger market segments like Web 2 or defense or media journalism or whatever? I think there's a risk of wanting to stay in your comfort zone, but at the end of the day, it'll just slow down the growth of the industry as a whole.
Yeah, I'd even dare to argue that we need definitely those people who purely specialize in the comfort zone to get really good in that bubble, become an expert in the field. Just as much the people who try to pop out of the bubble. the fresh perspectives create new use cases. If we were all cryptographers, we would have a lot of different algorithms. And one thing that we've also started noticing, especially with all of the recent political news, is the legal implementations of privacy technology and also implements within ZK. I would want to ask you this, Sasha, because you're directly working with biometrics and passports and general information. How are you, or is your company or Arimo, or your perspective at least, trying to deal with these legalities?
Yeah, probably I would say, yeah, I mean, you can be compatible, you can be regulated without compromising the privacy. So, for example, recently we have published a paper with Amin that you can build an FAQ list in some localized forum and create a proof of non-memberships. So, for example, you can vote with a proof that you are not included in the list of terrorists. And I believe that you potentially can build such mechanisms for any logic you want to prove. So if you, yeah, that's actually what privacy pools build. So when you're doing like deposit and withdrawal, they're locking like some black deposits, and you need to prove that you are not blacklisted when you're doing like the withdrawal. So if your rule, because you can program any rule. If you can create a program for any rule, it means you can cover that with zero knowledge. If you can cover that with zero knowledge, it means you can be regulated, you can be compliant without revealing personal information. But it's sometimes it's difficult, but it's yeah, still possible.
Thank you. One last question then. It's actually a nice one to finish off from, and I would also like to hear maybe a short answer from all of you, individually at least. So, ZK and blockchain has now been materializing for quite like a couple of years, I would argue. I couldn't directly put a number on it, but we're not directly at the beginning anymore either. If you would compare from where your experience started or your building with ZK started to now, what's the biggest advantage we've made? What's something we can be proud on that we turned into the reality of ZK?
One of the surprising things we're finding with the ZK verifier is, you know, we're trying to build something that is quite interoperable and working like natively verifying like a whole, like all the different proof types, proof systems. And you wouldn't think there'd be like that many being invented, but we're finding even within a single customer that we have, they themselves are like updating the verifiers all the time, adding new verifiers. We're like, crap, we need to like upgrade our product just to like handle them. So this isn't just like, it does feel like we've turned a bit of a corner. I feel like a few years ago, like progress was very, very slow. You might have heard of Starks, you might have heard of Snarks, you might know the difference between them, but now, like, it seems like every other week, every month, there's like brand new technologies, new verifiers that have new characteristics, new benefits, new trade-offs. And that for me is very encouraging to see that we're kind of at a turning point.
Yeah, definitely. When I started, we didn't have so many privacy preserving applications for payments, for voting, for like everything. But probably the final, this probably will be the situation when people will be out of the bubble. That's when we stop talking about ZK. So people right now, they're not talking about radio waves. They're not talking about Bluetooth technology, like about blockchain still, they are still talking. So when they stop talking about that, it means all these technologies are already integrated in our applications. And yeah, it will be a clear signal when we should stop.
Yeah, I think I totally agree. So basically, I still remember when we first started, we actually did some of the benchmarks. At that time, there are only a handful of offerings, and it's actually a very easy task to do. But now, if you look at the overall ecosystem, there are so many exciting projects. Yes, I agree. Every month there's a new paper, so you have to catch up. That's the hard part. But on the other side, that keeps everybody in the project very excited, right? It means we are onto something. And the moment maybe there'll be like no more, how do you say, the ZK summit, that means we have actually done that. Because it becomes so natural when I think about it anymore.
Okay, in my opinion, like when I started personally, it was only one practical proof system which called Grot 16, and there is no other like. Of course, there is some theoretical things, but it's complex to verify. It's you spend a lot of time for proving things, and you need to have like for Grot 16, for example, you need to have like individual setup for every ceremony for every circuit. So it's like it was a really pain in the ass. But right now, like if you see what's going on right now is like standardization of this industry, because right now there is a lot of risk implementation, risk virtual machines that you can just plug and play. You can get from this team. So it's like universal thing. So you need to start doing things. So only you need to know it's a Rust language, and you compile it to the risks, and it's already working like prototype. So I really excited that right now, like if we will have like, in my opinion, if we will do not see a lot of like use cases and all of these things, that means that this technology is useless, because right now it's so simple to make new things using ZK. That's my opinion.
Well, gentlemen.
1 minute. Yeah. You know what's interesting? Grot 16 right now still has the cheapest verification ever.
Yeah,
I think we can argue over coffee and beers on a lot of things here. So I wanted to thank you, gentlemen, for your personal, intellectual, and professional opinion and statements here today. Can I have a small applause for our panelists, please, from everybody?
Thank you.
Thank you, everyone. Next up, we have Guy from Phoenix talking about the future of privacy. Yeah. Will you put the video or turn on the one? Okay, so what's the end, okay? Thank you. Okay.
Hey, hi everyone. I'm Guy Ziskin. For those who don't know me, I'm the founder of Phoenix. I'm gonna talk a little bit about what we do, but from a different perspective. This is more of like an overview of privacy in the last decade, where I think we're going, and how FHE and Phoenix ties into it. So I think blockchains have been around for 15 years. We can be proud of quite a lot of accomplishments: censorship resistance, trust minimization, integrity. All those are wonderful properties, but as I'm sure everyone here, if you're here, there's one property we kind of suck at, which is privacy. Now, and of course, in decentralized systems, privacies are even worse than in centralized systems. But maybe some people in the audience can explain that, because I can't. Everyone's talking about privacy. So not just today, like in the last month or so, we've started to get like inbound, like we haven't received in many, many years. And I've been in this for 11 years. This is new. And I feel this is like, the gods of privacy have given us a second chance to actually make it right. Because I do believe it, that if we don't get it right now, when institutions are coming in, when normies are coming in and want to adopt these technologies, if we don't get privacy right now, then this really might be our last chance. So let's not fuck it up, please. All right. So this is a framework I've started to think about privacy recently. It's something that most of you would be familiar with, but I'm trying to give it like a different flavor. So if you look in the last 10 years since the original Zcash work and Enigma work, which I started back then, there's been like two branches of privacy that evolved side by side. One branch is the one I call Bitcoin inspired branch, is the local privacy branch. And then the other, which is more like private smart contracts, private compute, is the global privacy branch. Now, why local? Local because it's kind of like Bitcoin. You can't do anything beyond sending transactions around privately, but it's not programmable. Unlike global privacy, which is programmable. And then you have these weird in between kind of states, things like Aztec and Aleo, which start from the local privacy variant, and they try to push it towards private smart contracts, but they're not quite. I mean, they're not able technically to get as far. Maybe with some help from the Takeo guys, maybe yeah. But generally speaking, it has limitations, so it's somewhere in between. So this is a little bit of an unfair framing, because based on, if you just look at the previous slide, you would say, okay, global privacy great, local privacy good, local privacy not so good. And in reality, there's always a trade-off. And I do think we need to talk about the elephant in the room and talk about what are those trade-offs. The trade-off is mainly programmability. So global privacy is more programmable, but global privacy can be trust minimized. It can't, we most likely, I mean, some people believe we can, but most likely we cannot eliminate trust completely there, as opposed to things like Zcash, where it's zero trust, but it's not programmable. So that's kind of the trade-off. There are a few other aspects to it. But I do want to make the case for global privacy. And the TLDR is that programmability, in my opinion, is more important than zero trust. And why is that the case? Well, if you kind of look at like the development, like so many teams, so much money has been poured into privacy. So many teams have worked on privacy. And honestly, it did not get us far today. And I think the reason is that the cost to adopt privacy is way too high. And I don't just mean monetary costs. I mean, if you make it hard for developers to build privacy solutions, if you make it hard for users to use private solutions. I mean, again, Railgun is amazing. Those things, they push the envelope. But if I have to wait a minute just to send a private transaction, I'm not going to use it much. And most people are not going to use it. JP Morgan institutionals, if they even have a small risk, even with all the protections, that they might be entering a shielded pool with someone like the Lazarus group from North Korea, they're going to say, screw that, I'm not taking that risk. Thank you, but no thanks. And what happens is that when we are trying to get the zero trust local privacy solution, we get to this position where it's only at the fringes, it's only the cypherpunks. But if the lessons are teaching us anything, is that it's time to grow up, basically. With that said, we do need to address the problems with global privacy, and there are two issues. So the reason global privacy is not zero trust, if maybe you know this, maybe you don't, but it's because inherently, usually there's some decryption key, that allows you to decrypt the data. We don't want to give that key to anyone, so what we do, we split that key into validators, into a network, into trusted custodian, whatever you want to call them. It's a committee that you need M out of N of those nodes in the committee to actually decrypt something for users. That is the happy case. But at the same time, if those M out of N nodes are bad, they can decrypt information, and we as users won't know that. So that is the trust issue. I welcome you to go into the blog that I posted a month ago. What I've been trying to do is to think about how can we minimize, we can't eliminate, but how can we minimize and harden this to make it better such that this is not as big of an issue. I do believe we can get very, very far. But then I do want to mention the other aspect. So there is moonshot research being done. I'm a bit skeptical still, but I've been convinced wrong. Things like I/O, so basically obfuscation, things like traceable secret sharing. I mean, those may actually give us cryptographic guarantees that can actually eliminate or decrease the problem. Now, the second problem that global privacy solution has, they only allow confidentiality but not anonymity. So pausing for a second, who knows the difference between confidentiality and anonymity? Good, most people. For those who don't, confidentiality is the data. So in transactions, you encrypt balances and you encrypt amounts when you send. But if you're doing something like private AI on chain, so now you might decrypt the model weights or the prompts that users are sending. So it's like encrypting all data that's like inside. Anonymity is about the metadata. It's about who's interacting with the system. When it comes to transactions, it's usually the sender and receiver of the transaction. So global privacy solutions like FHE, MPC, TEAS, they do not inherently provide anonymity, which is why I'm stating it here. but there are solutions to do that. We are working on it internally. I know the Takeo team has just released something amazing that people should look at. It's called Oblivious Maps. So these are like oblivious RAM-like solutions that actually do solve it. And I do believe that within a year from now, this won't actually be an issue. So let's say in a year, it's really going to be just number one. Okay, now, obviously there's some bias with Phoenix, start with FHE. I have a bias with FHE, so take it with a grain of salt. But I do believe that FHE is really the key to unlock global privacy. And if you think about it, it's almost like a match made in heaven. Like we want to be able to compute over private data. FHE is a type of encryption that allows anyone to compute over encrypted data without decrypting it. So exactly what we want. The issue that I usually hear, and everyone in the team hears day after day, is that FHE is too slow. And I'm here to dispel that myth. I don't blame you. Even if you're a cryptographer or a developer and you say that, or someone smart tells that to you, well, you can quote me and tell them that they're wrong. But the reason they're wrong is not because they're not smart, they're very smart. It's very, very hard to follow the pace of research on any one domain. Like I can't follow all of the newest like ZK constructions on a daily basis because that's not what I'm doing day in and day out. I use ZK at the edges, but that's not my expertise. And same thing, like if you have a cryptographer working on ZK or MPC, he may not know the state of the art with FHE. But it is accelerating very fast, and it is going very fast. And I want to give you two examples of that. So one of them you may have seen, but the other you haven't. Okay, so to scale FHE, I want to split it into two, okay? So in every FHE, there's MPC. Well, not in every, but in the FHE that we're working on, it's called threshold FHE, there's MPC. That's when you want to read data. So I'm going to give examples. Let's say we have confidential tokens on Ethereum. They're encrypted with FHE. Now, I, as a user, want to read my balances. How do I do that? I ask the network, who spreads the key around, to do something called the threshold decryption protocol, which basically decrypts my balance for me without letting anyone else, as long as they follow the protocol, as long as they don't all of them collude or something, as we discussed before, no one else can see my data except me. So that's when you read state from a blockchain. The other, and that's basically MPC. The other aspect is writes. So these are like your private smart contract executions, but these are being done on FHE, with FHE itself over encrypted data. So I'm going to start with what we did with the first one. So this was a real bottleneck at Phoenix, and I will give you an example why soon, but a real bottleneck. So like the state of the art was maybe 10, like a throughput of 10 decryptions a second. And the latency was about half a second. But we did quite a lot of work. We invented a new protocol, and now we got that to real time. So throughput in the tens of thousands, latency less than 10 milliseconds. I'd argue that's good for anything we want. I'm not going to talk about the details here. I want to keep this broad. But if you do want to see the details, this is a technical paper. It's already implemented into Coffee testnet. Lior, one of our devs, he spent like 4 weeks not sleeping to get it done, but it's done. And so if you want the details, you have it there. We also presented it at CCS last month. It was very well received. Okay, so why is this important? Why is this actually a problem? Well, we ran this back of the envelope calculation when we were building this. So imagine you have a wallet, and now every asset, every token is encrypted. So now let's say in your wallet you have like 10 assets encrypted, and you want to read the balances of those 10 assets. I mean, who doesn't like check like every day? I do. Maybe not now. So you know, if I'm one user, that's 10 requests. But if 1,000 users come in, that's 10,000 requests at once. If you plug the numbers I put before, the old numbers, that's going to take like half an hour to get a response. That doesn't work. But with the new system, this is instantaneous. So it takes less than a second, which I think is pretty cool. And now I want to move from reading to writing, or basically FHE compute. So this is admittedly the harder problem to solve, not that the first one was easy. But first of all, let me say this. Most people don't even realize that FHE, like actually computing via FHE, can do something like 10 to 100 TPS today. That's already usable for many on-chain applications. However, this is not sufficient. This is not why we're here. We want to build like global scale payments. We want to compete with Visa. We want to allow private AI, real private AI, not using TEs, no offense. And for that, we need to go and be ambitious and try to break 1K to 10K plus throughput barrier. And this is the first time I'm showing this ever. We'll talk a lot more about this in the coming months, but this is actually big. So that's exactly the mission we set as a group around last spring. So this has been like 6 months of work. And the goal was to build an FHE scheme that is throughput oriented first. And this scheme, so what we use today, what everyone in the industry uses today is something called TFHE. That's a variant of FHE that people use. DBFV works very differently. It's about, on the same hardware, it gives you about like 1000x more throughput. And it's very important. It's not that you're taking more hardware and scaling it, that's cheating. On the same hardware, you're going to get about 1000x throughput. And it's also much, much better at doing encrypted arithmetics. I mean, you can see the numbers. These are very initial numbers. They will change, but it's orders of magnitude faster. Now, there are some areas where this is going to be either not as fast or maybe even slightly slower, but not meaningfully slower than TFHE. And when you combine all of that together, we do think this would be the end game to solving FHE, this for the next few years. So we'll have a lot more to share about that, but I did want to give you an initial look. We have a paper submitted. We're kind of refining it, and we'll post it publicly in the next few weeks, or maybe a Q1. Same for the code as well. And what can this unlock? Well, I do think this can unlock a lot of things that we're not even really dreaming about today. So I touch a bit on private decentralized AI, and I do think this is important. And there's actually some teams who came to us and asked, like they said, they're using TEs for private AI, but can we do that with FHE? That was one of the motivations to unlock this. Another one is really private DeFi and private payments at scale. I mean, you're seeing Tempo, Arc, all those, like they're not gonna work with 100 TPS, no offense. But they are using TEs right now because they don't have something better. If we can show people that FHE can scale to 10K TPS, I think it's a different ballgame. There are other many use cases that you can actually get, like RPC nodes. I mean, people use RPC nodes. You go to Etherscan, you send queries, they see all your data. Well, what if you can do that with something called the PIR, which leverages kind of FHE, then you can get anonymity from RPC nodes. And anonymity, you can actually build anonymity solutions. Remember the problem I mentioned before? This actually gets us much closer to anonymity as well. So many, many, many aspects that this unlocks. With that, I'm doing a quick detour. This was a highlight because you're here, you're seeing it. But I feel our team has been a bit too modest. They've done an amazing job, not just on the engineering side and the research side, but really like the UX that you can get with things like confidential DeFi is already like way, way better than what we've seen, I think, originally. So if you don't know, many of us worked on Secret before. We never had UX at that level. So I'm really excited about that. I just want to show you 1.5 minute demo of what like confidential DeFi looks with FHE in reality. I hope it works, the video. Yeah. So this one is like NFC payments, and then it would be like Bluetooth payment from one phone to the other. All encrypted. I mean, if you would have told me 2 years ago that we will get to this level of UX, I would not have believed it. This is actually really cool. And with what's happening, oh, okay. And with that, I'm actually done. So bottom line, FHE is not so slow as you thought. It's gonna get way, way faster in the next few months than you can imagine. And I do think that this is our final opportunity to get this right. So no pressure, Phoenix team, no pressure, anyone working on privacy, but now is our prime time. And thank you very much. There's a couple of things here you may want to scan. For that.
Thank you to Guy. Next up, we have Zane from Horizon.
Hello. Hey, everyone. Welcome. I'm Zane, CTO of Horizon Labs, and I'm thrilled to be here to talk a little bit about building future-proof encrypted dApps and how to practically achieve compliant privacy. Special thanks to Paolo Cappelletti, who's the brains behind all of this. He's the engineering manager and lead for Horizon. These are the broad strokes that we'll cover. We got a little bit of a backstory around dApps, privacy, liquidity, and then our contribution as the Horizon protocol. Just like a slightly deeper dive into the Horizon architecture, some key workflows, and a summary and roadmap. Backstory. A few of you are familiar with this. This is Ethereum's transition triangle from maybe a little bit over 2 years ago in one of Vitalik's posts. He talked about the 3 transitions that are needed to take Ethereum from an experimental technology to one that's mature and ready for the masses. On the bottom left, you have scalability. On the right, usability, and then privacy. The bottom left, we know that scalability is in full swing with the roll-up-centric roadmap. L2s such as Arbitrum, Base, doing really well. Usability, smart contract wallets, ERC 4337 is live, being adopted pretty quickly. On the privacy end, we're still early with stealth addresses. We saw some stuff from Kohaku this week, privacy pools, and encrypted mempools. This is some photos from just a couple of days ago, Ethereum in 30 minutes. This is Vitalik in his usual annual chat around Ethereum, and there was a quick slide on privacy. He had mentioned that it's multifaceted, multi-layered, and you'll see a little bit of the work that the Ethereum Foundation is doing. But it goes beyond Ethereum. This is an A16Z State of Crypto report from just last month, and it just says that the need for privacy is more urgent than ever. You see that privacy-related Google searches have increased significantly. Total flows through Railgun steadily increasing, and the Zcash supply in the shielded pools has increased as well. Many notable privacy developments, such as the Ethereum Foundation, Paxos and their partnership, Zcash's wallet, Noir, and the sanctions being lifted from Tornado Cash. For us at Horizon, We believe that privacy is a practical concern, one that needs to be addressed now, not an ideological one. This is the world that Horizon is building for. Who is Horizon? We've been around since 2017. So with the early privacy coins like Monero and Zcash, we were a fork of Zcash. And the landscape of blockchain privacy is constantly evolving, and we have privacy chains like many of the projects you've seen here, privacy apps, and we've transformed our project into one that's more based on compliant privacy. And I'll go a little bit into that. We did a recent migration of our entire chain and token supply into Base. This is another view of like privacy efforts. In the blue, you'll see Coinbase's Base, and many of the L2s have significant liquidity. And so as of just a couple of days ago, Base has a total value secured of 13 billion, only surpassed by Arbitrum, and both of them are always neck and neck. One way to view this is that many of the privacy projects, they're not directly tapping the liquidity that's there in the L2 spaces. Whether it's Zcash, Monero, Aleo, Secret Network, they're all unique in the way they are addressing their protocols. At Horizon, we want to focus on where the liquidity is. And we're building this privacy layer for Base. We were one of the first projects when Base launched their L3/app chains. So we were part of the initial cohort. So I'll go into a little bit about the high level of our protocol. The Horizon protocol consists of two things. That L3 chain that I mentioned before, and it's an L3 blockchain rolling up to Base, and another component, which is a trusted execution environment, a TEE that we affectionately call the Horizon CCE, Confidential Compute Environment. These two things, that compute environment acts as a coprocessor, and these two things together, they form this layer that allows dApps to build on the chain and have built-in regulatory compliance, as well as access to Base liquidity. And how does it all do that? I'll go into it on a high level from a core architecture standpoint. The first component is the Horizon chain. We are an OP stack-based rollup, settling native DA on Base. We currently we are in the process of launching to mainnet with several privacy-oriented apps. We have a ecosystem fund called Thrive, and that chain interacts with the coprocessor, which is the confidential compute environment. The chain also has access to Base liquidity through Layer 0 Stargate. I know we're always constantly looking to improve this various bridges, but we work with Stargate via Layer 0's interoperability stack so that we have this unique cross-chain liquidity transport protocol, and liquidity pools of native assets are deployed on our chain. And this guarantees instant finality with no waiting time for challenge windows. The second component on a high level is the confidential coprocessor. Note that everything in this protocol is encrypted. So all private data is, when it's computed inside the TE, and encryption outside is pervasive. So the workload's moved off-chain, and attestations are verified on-chain. dApps are essentially deployed as WASMs inside the confidential compute environment so that they run there, and then they're encrypted after. And I'll go into that a little bit. On a high level, this is a DApp view of how things interact. So in the blue is the DApp front end. Included with our system, the DApp can access our on-chain smart contracts to enable this orchestrator here, which is the Horizon Secure Processor Manager. It is the gateway into the CCE, and every time the DApp runs, it runs its state transition in the CCE, and then it gets saved into an encrypted data layer. What do dApps have to do? Really, all they do is need to run their application code as it is. It's packaged as a WASM, so whatever languages compile to WASMs, such as Rust and Go, and the DApp UX. And applications just focus on their workflow. That includes the private state, input actions, output actions, and any de-anonymization requests. So in terms of private state, the state is fully encrypted and persisted into our reliable data layer. Any actions, whether it's transfers or various action types, they're encrypted as well. And then you, as a developer, define the events, and our platform will encrypt them. And then in terms of de-anonymization, you, as a DApp, can define the granularity of that. And so our protocol essentially does the rest in terms of achieving privacy, and the application code is deployed in a WASM inside the T infrastructure. The encryption and decryption takes place automatically, so everything outside the T is encrypted. And then auditability allows the DApp to be flexible and share data as needed. I'll go through a couple of key workflows demonstrating this. The first one is the DApp access to the trusted execution environment. On the left, you see that when a DApp first enters, it registers with our smart contract. And after registration, any interaction that a user has is encrypted. And if they're coin transfers, they're locked inside our smart contract. And then with the action, the app is loaded into the TE with the app state from the data layer. And it's run there statelessly. And then as an input, it will take in the new state. And as an output, it outputs the previous state, the new state root, a list of user events, which is encrypted, and a list of withdrawals to be executed. Everything is signed with the T signature and verified on-chain. On the opposite side, you see on the bottom here is kind of the authority workflow. This is the integrated compliance workflow that we bring. And an authority, it could be anyone that registers with our smart contracts. They ask for de-anonymization requests, which essentially are reports for a specific DApp. These are submitted to the Horizon smart contract, and then the legitimacy of the authority is checked on-chain. As part of the framework, the DApp creates the report once it's loaded inside the TE. And then a private report, which is encrypted with the authority's private key, is produced by the app and then saved to the data layer. At any time later off-chain, the authority service can request access to this report and use this key to decrypt it. That's on a really high level how the two components work with each other in some workflows. So we went through how it's really anchored to base, the chain, the CCE, the Horizon protocol as a whole. And we want to share some near-term things that we're working towards. We're currently in testnet, and we're shooting to deploy to mainnet within the next month, deploying it as an OP Bedrock rollup, and then incorporating fast bridging through Stargate. Next, we'll release the Horizon CCE to complement it as part of that two-pronged protocol, and then work towards DApp-centric toolboxes for KYC, accreditation, and privacy-preserving identities. We want to improve the native bridge, and we'll include validity-proof frameworks such as OP Succinct or Ristio Kailua, and that's bringing down the traditional 7-day optimistic challenge window down to minutes or under an hour. So that's on the near term. All those near term projects fall under stage 0 for us. Our goal is to have this trusted execution environment that's mature, performant, and deployable now so that it can be used. Over here is a list of all the projects that will be deployed on our chain, and many of which are part of our Thrive program. Stage 1 is including several enhancements that our research team is working on that pushes the frontier of research. We have a project called drip filters that can be applied to many dark pools so that you can't see, for smaller pools, you can't see the amount going in directly and going out. We are also working on a project called auditable private logs, where logs that are encrypted, you could kind of search within those logs for certain things. Stage 2 is replacing that hardware T with a cryptographic T. And so that's a little bit longer term. And then stage 3 is more around post-quantum security. So that's in a nutshell what we're planning to do, and contact us. This is our site, horizon.io, and news coming soon tomorrow. And connect with us on X. We also have a booth outside, and many of our team is here. Thank you.
Thank you to Horizon and Zane. Next up, we have Wei from 1KX.
Right. I promise you, I know all of you have been here for the entire day probably, and you've seen many, many presentations. And hopefully you'll learn something new today and have some food for thought going away from this conference. So my name is Wei. I've been thinking about designing, building, shipping, and investing in privacy protocols for the past 4 or 5 years. And I think there's one problem that I really want to highlight at the current moment. There's a lot of attention on privacy, and there's not enough about this one thing that I'll talk about. And I call it on-chain privacy trilemma. So let me first say that why do I call it on-chain privacy? Why is it not just a privacy trilemma? I think it's very important to talk about what type of privacy we're talking about whenever we talk about privacy. We're at Encryption Day, and that's a particular method to get privacy. But encryption gives us many forms of privacy in the social context. So largely speaking, right? So we'll have communication privacy. Think about your text message on WhatsApp or Signal, and we'll have financial privacy. So these are on-chain blockchain protocols, right? We use your bank application, and we also have, for example, voting privacy. And all of these categories of information, of actions, are different. In a social context, in an ethical context, how do we deal with private information? And today, I'm going to be focusing on financial and asset privacy on public blockchains. And so what I say would not apply to all the other stuff. Okay, that's a disclaimer, and I think it's important to do this. All right, so first claim, on-chain privacy is like nuclear physics because it is a dual-use technology This is very powerful. It can both empower individuals, right, like nuclear power plants, cheap electricity, but it can also empower nation states. On-chain privacy can be like nuclear weapons, and it could be pretty bad if the wrong actors, if the wrong nation states get their hands on these technology. Why is that? Well, because cryptography rearranges power. It just sort of turns out cryptography can be used to build unstoppable on-chain finance, where you can move billions of value in a blink of an eye. If you can also protect your identity, and if you can actually hack other on-chain protocols, then that's a really a problem, right? And I think as builders of privacy protocols, we need to think about how we're leveraging cryptography to rearrange this power. And I think we'll have a moral responsibility to think hard about this. Here is the on-chain privacy trilemma. Between the following three properties, maximal usefulness, sovereign privacy, and threat resistance, I will define each of the three terms. We can only choose two of the properties, but never all three at the same time. Okay, what are these three properties? So let me go one by one in detail. First, I'm gonna be talking about sovereign privacy. Privacy is a fundamental human right, as defined by the Universal Declaration of Human Rights. There's Article 12, right to privacy, and Article 17, right to own property. And what do we mean by sovereign? So Eric Hughes wrote, we must ensure that each party to a transaction have knowledge only of that which is directly necessary for that transaction. An anonymous transaction system is not a secret transaction system. It should empower individuals to reveal their identity when desired and only when desired. So there's this crucial point on your information is private as long as you don't decide to disclose that, right? So that's the sovereign aspect. Once something is private, it should stay private. No one else should be able to break into that, right? There should be no information backdoors. That is the notion of sovereign privacy. And in a blockchain context, it means that transactions on chain should happen by default in a private manner. And you and only you should be able to reveal that information. Okay, so it's a very, very powerful property. And how many of you think that we should have sovereign privacy for on-chain transactions? Okay, I'm not sure why some of you are not raising your hands, because this is very important property. But let's move on to the next one: maximal usefulness. What do I mean by this? So on-chain finance today is actually very magical. Anyone in the world can create an address and get sent a lot of money and move that around by tokens, get yield, do lending. And if you look at the on-chain stablecoin payment volume today, we have already exceeded that of Visa, and we're quickly approaching the volume of ACH payments. And that is what we want for on-chain finance. We don't want velocity limits. We don't want KYC gating. We don't want you have to like KYC your passport to be able to use something, right? We want on-chain finance to largely work frictionlessly as they are today. And that's what I mean by maximal usefulness. Can on-chain finance work the same way that they do today without whitelist identity systems, things like that? How many of you think we should have maximal usefulness for on-chain privacy protocol? Great. Okay, more hands. Lastly, what do I mean by threat resistance? What are threats? Very simple. We see them every year. We see them every couple of months. On-chain hacks. This is a graph of on-chain hacks for each year. For the past 4 years, we have seen over 1 billion of value hacks every single year. It's not slowing down. It is happening. It is real. It's going to happen. We'll have a solution for this, right? There's key loss. It's almost really hard to prevent. And just more recently, we have the largest hack to date the Bybit/safe hack. And there was no on-chain smart contract that was hacked. It was purely a social engineering attack, right? Of the software on the software and the OPSEC side. So let's actually look at what happened with the Bybit hack. 2 months after the hack, about 70% of the funds are traceable. Only about 30% have gone dark, and 4% was actually frozen. Right. So you can think if it's traceable, it's either we can't trace it anymore because it went to some centralized exchange and the exchange refuses to cooperate, or it goes into ternary cache, or it goes into another mixer, or it goes into some intermediary like an off ramp, but they're actually collaborative with the authorities, and they're like, okay, well, you're telling me this is from a hack, I'm going to freeze it. Okay, so it goes from traceable to either dark or frozen, and I claim the on-chain system today is actually quite threat resistant because we're actually able to trace most of the activity. 70% is still traceable after 2 months, meaning the attackers wasn't able to get what they want, right? And so we actually have really good threat resistance, even though we have very, very strong self-custody properties on public blockchains. Because firms like Chainalysis, TRM, can actually generate these list of malicious addresses and update them very, very, very fast. And so that is what I mean by threat resistance. We should try to preserve this property. When a hack happens, we want them to be potentially freezable, right? Like this is not in protocol, but there should be mechanisms to like trace these things so that involved parties like intermediaries and off ramps can potentially freeze funds. How many of you think that we should build threat-resistant protocols? Great to see hands here, because whenever I give this talk at a very cypherpunk crowd, people will say no, and I think as it's the discussion, right? It's a subjective thing, and I think it's important because there's too many hacks on chain. All right. Now we have a problem because if we want all three properties, I claim we cannot get all three. And I have a technical proof of this in a longer talk that I've given at ZK Summit earlier this year. And I will not go into details in this talk. But what I would do is to actually examine the trade-off space. So whenever we'll have a trilemma, we'll have three different categories of solutions. And I'm going to use the following naming for each category. So if you are maximally useful and self-sovereign privacy, meaning right, you try to ignore threat resistance. You're like, okay, I don't care about the hacks can be laundered. I just want to have the best privacy. That's called idealized privacy. If you give up on the usefulness, I call that category throttled privacy, meaning there's some deposit delays or controls. And if you give up self-sovereign privacy, I call that responsible privacy, meaning there's a responsible information custodian. It's not to say the other solutions are not responsible. It's just a name. Let's go into how this actually look like. So on the idealized privacy side, we actually have really, really good technology to be able to enable idealized privacy. So if you just want the pure cypherpunk privacy, it's actually very easy to build theoretically. We use ZK mixers. We can use MPC FHE or TEs to get confidential states, and everything can be hidden by default. You can interact with public on-chain protocols, and and there's, I would say, very little hurdle for someone to build something like that. And the hard part is to actually try to think about threat resistance. And if we want threat resistance, there's going to be two categories of solutions, which is one, throttle privacy. And over here, I would say, if you think about like privacy pools and Railgun, I think Aztec is also thinking in this direction. So in these protocols, you have things like proof of innocence, deposit delays, and these are basically gates to money velocity. So there's money velocity limits, and because once something have happened, you can no longer reverse it. You can no longer decrypt it, right? We have this strong guarantee on privacy, so therefore we have to limit we have to make sure that, for example, Chainalysis can give us the most up-to-date list before we allow a deposit to go through. Because if we do it too quickly, then it might be discovered at a later point that it is a hack. So, and then in the final category is what I call responsible privacy. So over here in this category, I think you have seen a lot of companies today, FHE solutions that use MPC can potentially decrypt information that's in that system. If you use TEs, right, you can have programmable decryption of certain information that's in your system. So any of the system where the information is stored in TE or MPC could potentially build in mechanisms for decryption. And there's a information custodian. And in fact, centralized systems like what zkSync called zkSync Prividium is also in this category, right? If you have a blockchain that's actually private, but there's just an operator that can see the information. And I think this is a pretty important point in the trade-off space. I'm giving 2 examples here, but there are many, many, many more. And obviously, a lot of pushback that I always get whenever I talk about this category is that people ask, well, isn't this just a honeypot? How can we trust this operator to not use the information to their own benefit? Well, I think that is the open question and challenge. Can we design the systems so that the decryption authority is not misused, right? Can we have an MPC system where every single decryption request is publicly auditable? And so we as technologists should think about how to build better systems to have better accountability to the decryption authority. And yeah, so I think this to me sums up the core challenge that I see in what every single privacy project I go through. They always go from the top left, let's build the best privacy, and then realize, okay, I need to add threat resistance, and they think about, okay, I'm going to preserve privacy as much as possible. But then eventually, a lot of projects, right, just end up on the top right, which is, okay, we have to have some form of decryption authority. How do we best control that? Yeah, let me just actually, one point on this slide is I think both category B and C are very, very valuable. And I personally think we should build more privacy solutions in C, meaning there's decryption authorities. But really, I think it's equally good that we have more privacy protocols that are throttled, but are immediately useful. And both of these solutions together, I call them pragmatic privacy. And another way to think about giving up self-sovereign privacy is that the opposite of self-sovereign privacy is actually the freedom of disassociation. I think Amin actually gave a talk earlier today on this exact thing. So I'm going to skip this because, yeah, I think you get the point. You can read the tweet. So, and let me end with a quote on what is actually privacy. So privacy is not absolute, and the best definition I found that define, how we should even think about privacy is privacy as contextual integrity. Privacy demands that information gathering and dissemination be appropriate to specific contexts. What does that mean? Well, if you have your information that you share with your doctor, that information should stay private to mostly everybody, unless a doctor maybe need that information, right, to make that diagnosis or share with your other healthcare provider. Your DM with your friend should stay private. Government should not be able to see it, and other people should not be able to see it. But your communication at work might have record-keeping requirements, right? And your transactions on chain, well, it should be hidden. It should be hidden from public view. But maybe if you're transacting more than like 100 million or $1 billion, then like maybe it should be completely hidden if you're actually moving markets and earning significant real impacts. And I think the appropriateness of information flow is very subjective, and some will say maybe right it's not even intersubjective, meaning it's really hard to get consensus on. Different jurisdictions have different ways to regulate these things, and I think as technologists, as privacy advocates, this is actually the number one priority. Is we should be discussing what is the appropriate amount of privacy in different domains. And I think for on-chain privacy, maybe we should think about how to make things threat resistant, but maximally empower individuals. And I don't think that's going to be an impossibility. So let me end here. I'm not sure if we take questions, but yeah, I'm happy to take questions if I have the time. Thank you all.
Thank you, Dwayne. Next up, we'll have a panel featuring Phoenix, Predicate, Masari, and Optalysis. Thank you.
Thank you. Yeah, I was gonna say, I was like, I didn't know you were gonna. But everyone's ready.
Is everyone ready? Is this the last one of the day? Is then the drinks? Okay, so we get drinks after this. So we're here to talk about, I think, the long tail that all of us are focused on, which is ultimately institutions. No matter what corner of the crypto world you're focused on, we all ultimately want to get in with the institutions. And I guess before we can do introductions. I'm Ryan. I oversee BD here at Phoenix, and I'm with a lovely crew. Oh, and yourself?
Amazing. My name is Kushi. I lead business development at Predicate, where we build on-chain policy enforcement. And so basically what that means is we enable blockchain teams to set up compliance systems for their applications, including things like anti-money laundering, customer due diligence. And we've worked with a lot of privacy projects on building on-chain compliant privacy, such as Alio, Aztec, and Maiden.
Hi everyone, I'm Alice. I'm a research analyst at Masari. I cover DeFi and privacy tech.
Hi, I'm Joe Wilson. I'm the head of strategic innovation at Optalysis. So I focus on business development and communications.
Hey everyone, I'm Lior. I'm leading the protocol at Phoenix and I'm doing code.
Great. Okay, so with that, so institutions have spent the past decade encrypting basically everything except the part that matters, which is the moment that you use your data. That gap has become the biggest liability in digital finance. And with that, it's not about hiding anything anymore. It's about choosing when, where, and how you can operate safely in a digital world. And with that, today, exposure is a big challenge because we don't want to lose customers, we don't want to lose compliance, and we don't want to lose our competitive edge. And so that shift is ultimately what we're focused on. And I guess my first question for you guys is, what do you think has changed in the last 12 months that have contributed to this moment where people were like, okay, privacy, we'll eventually get to it, to let's go? Who wants to start?
Okay, I wasn't ready, but I'll start anyway. I think there have been a lot of things that have changed in the last year. In fact, the last year was arguably probably one of the most pivotal, the most progressive for digital assets. So a lot has happened. I would say the biggest one that has led to the go ahead, like, let's embrace this world of privacy has been a lot of the regulatory adoption and openness that we've seen recently. This is across the world, not just in certain countries, but we've seen the United States pass legislation for digital assets. We've seen Singapore, we've seen the EU, we've seen Abu Dhabi in the Middle East do the same. So we've seen a lot of progress on the side of regulatory development, on guidance, and none of that really covers privacy yet. But what it does do is it increases interest in digital assets. It shows that these are a class of financial products that is here to stay. And so we've started to see interest from financial institutions, from regulated bodies, and from developers that want to understand how this works, and users that want to understand how this works. And so a lot of the go ahead on the privacy side has come from the fact that we now want to make this tech usable for users, for institutions, for financial products. We want to make it possible to interact with digital assets, to interact on the blockchain, and to do so in a way that is private. And so now I think we've seen this big push on privacy and on chain privacy, which honestly has been around for years. But we're seeing a much larger push recently to attract those users, those customers, and because we've seen more adoption from regulators and financial institutions.
I think this question could be broken down into what's happening within and outside of crypto. So within crypto, Ethereum Foundation has launched very clear privacy roadmap about just bringing privacy on chain, and EF also launched this privacy stewards of Ethereum, which is a dedicated group of researchers and developers bringing privacy tech on chain. And also, even for non-EVM chains like Solana, they just launched confidential token standards. So everyone is making an effort here lately. Outside of crypto, this cycle is different in terms of we're seeing institutions for the first time pouring in billions of dollars into our industry. And it's time that we need to transform our industry from a casino to a high standard global financial infrastructure for the institutions. And privacy, I believe, is the missing legal to achieve that vision.
I think there's positive reasons driving the move towards privacy. I also think there's actually some pressure as well coming from the fact that you are now starting to see stable coins become very embedded. I think they replace some of the functionality that some of these institutions were fulfilling. I think there is definitely also a pressure from underneath to actually stay ahead of this because you are now starting to reach the point where you could potentially be outcompeted. So I think there are both positive and negative drivers in this space. I think also, like you say, the evolution of privacy tech throughout this last year and really even before then as well, it is reaching a point of maturity where I think you will find a tipping point where all of a sudden all the pieces are in place for you to be able to construct these kind of privacy-based workflows for replacing certain aspects of the infrastructure that these companies are using.
Yeah, I mean, I think that after 4 years in the industry of privacy and blockchains and different protocols, I think that, yeah, the technology is different now, but it was there always. And I think that I actually believe that the elections in the US started the thing with people, and especially like institutions are not afraid anymore to use privacy as a thing. And I think it was a great beginning. I think other countries just went through with it because of the great success in the US. And I think like for us, it's a huge advantage.
So, as we all know, there's no shortage of three-letter acronyms when it comes to privacy, whether that's TEs, MPC, FHE. But institutions don't buy that. They want trust, performance, and clarity. And so I'm just curious, in no one order as we can, we'll start with you, Talysis. Are TEs still viable post-Spectre, or have we crossed a trust threshold?
I mean, post Spectre is kind of an arbitrary point for hardware security. You could go way, way back into hardware history and you look at things like Tempest regulations, you look at the rise of FIPS and other sort of hardware aspects. I mean, yeah, sort of like Spectre and Meltdown, they broke TEs and then they made a fix for those. And then you find another break further down the line. You're always trailing innovation in breaking these systems because you simply cannot know ahead of time where those vulnerabilities are going to be, all of those vulnerabilities. So I don't think it's any one particular point where you get to the point where hardware security becomes troublesome. I think you have to, I think sort of 70, 80 years of encountering problems with side channel attacks is probably long enough for you to be able to say that maybe it's time to just delegate the security to cryptography rather than to hardware.
Thank you for that. And I guess on the compliance side, what are you seeing? Like, is it possible to not reveal anything and still be regulatory compliant? Like, if you really think about it, or is that just a far off dream?
It's a great question. And the three-letter acronym thing was funny because ZK just got pushed off the side. But it is possible. I mean, compliance is a range, it's a spectrum, and especially in today's world, there is no set of rules where if you do XYZ, you're magically compliant. It's all about following best practices and doing everything you can. And so, in a world that's fully anonymous, it is still possible to follow best practices. And we see privacy projects attempting to do this today. Like if you come across any type of fully anonymous system, there's usually a threshold that you cross where on one side it's transparent, at least in some manner. So maybe it's pseudonymous. And then you cross that threshold into a black box that is fully anonymous. Typically, when a privacy project wants to implement full anonymity, at that threshold, they'll implement whatever policy, compliance, or risk management rules they want to enforce. And this allows you to at least ensure that everything entering that black box is entering in a compliant manner. Now, what happens in that black box is something you still need to probably track in some way. If it's a single transaction, it might not be a problem because you check every user entering, that user interacts with another user, you know all the users are compliant, and so you have some level of understanding of what's happening in that black box. If that black box is, for example, a fully anonymous blockchain, there's a lot that you could be doing in that black box. And so a lot of companies will have different fail-safe mechanisms in place, such as viewing keys, that they'll provide to trusted parties in the event that something might go wrong, or in the event that they need to make sure that nothing illicit happened. And so fully anonymous systems are possible. There are ways to ensure compliance for people entering that ecosystem, but it's also important to ensure that you have some level of understanding of what's happening within that ecosystem as well.
And on that note, I feel like we talk about these things as they're possible today or tomorrow. And I'm curious from like any hot takes on timing. Like, is this, realistic today, tomorrow, this year, or are we talking years down the line? I guess for all of us.
I can speak on this for if you want me to.
Yeah, please go ahead.
From a policy perspective, this is a long way down the line. Like T's, ZK, FHE, whatever you want to choose for privacy, regulators, policymakers, all they know is that privacy is a thing. And for years, we've been having privacy summits in DC. We've been having privacy workshops with regulators and policymakers. And those have been going on forever, not just because privacy is popular right now. And these are all educational systems in order to help these people understand how privacy works on chain, how privacy works, period. But there is a lot of progress that needs to be made on just understanding privacy. And then once these regulators and policymakers understand privacy, then we can begin on the approach towards education on how we can regulate and ensure that privacy is compliant and safe to use. So I do think there is a long way to go before we have compliant on-chain privacy. And that's why today the best thing we can do is implement best practices as we build towards that world of compliant privacy.
I think there's also an additional aspect to this is if you look inside a financial institution, really a financial institution is like 30 or 40 different platforms, like wearing a trench coat. And the reason for this is because institutions don't have the option of like stopping and resetting and rebuilding themselves, around a particular tech stack. When a problem arises, they find a solution. So maybe, all of a sudden a new regulation comes in, you need to find a compliance platform that you're plugged into. And that leads to a very fragmented tech stack and ecosystem, but it is also a solution. When you start to propose moving more and more functionality onto the blockchain, then yeah, maybe you can do that with, additional protocols. Maybe you can find technical solutions to that. But I think it's going to be much easier for institutions to adopt these things as solutions if you have a good ecosystem of composable privacy. So you are able to fix these problems more readily on the fly and do the sort of blockchain equivalent of finding the new solution when a new problem arises. Because you will find new problems, you will find new regulations. And if you're not confident that the tech stack is going to be adaptable to that, then I think you're going to have real problems with adoption.
I guess on the Masari side, like from a macro perspective, what are you seeing, demand-wise from institutions? Are they asking for anyone primitive? What seems to be the model that makes the most sense for what they're looking for? I guess right now.
Thanks for the question. From a macro perspective, so traditionally in finance, big institutions' money flow and trade via something called dark pools. Over 50% of large trades are executed via that thing. You're able to hide key transactional details until the final settlement. But this is something that we're missing on chain. I would say transparency on blockchain projects is a bless, but also a curse sometimes. Because for institutional players, there's no way you want everyone to see every time you want to make a trade. You don't want your strategy exposed in public. We do have some improvements, like we have intent-based trading architecture that allows off-chain solvers to route the best trade for like larger sizes trades, but that's not enough of a privacy for institutional demand. We want to achieve a level where key commercial transaction details are all hidden from the public while having this compliance layer where users are able to attest when the regulators require like certain proof that your fund is coming from a legitimate source.
I guess on that note, about demand from all of these different corners, where are you seeing demand? Like, what are the questions that you're getting from institutions these days?
Yeah, as I said, I'm more on the technical side than being asked this question. But I think that what institutions are looking for is, on the one hand, we should be compliant, right? We can't stay and say like you can't access the data when you actually need it as a government. But then on the other hand, we should keep the privacy in place. So I guess like there, I think most of them are trying to find like the best the best combination between the two, finding both compliant and yet private solution. I think that like things that people might think that institutions will ask, such as, I don't know, performance and stuff like that. If anyone tried to wire funds from his bank account to another bank account, I don't think it's a question that actually will be asked. I think that the technology is there already. I think we should be way more compliant in order to make sure that it will be adopted.
I think I'd agree with that. I don't think, obviously, a lot of the people in this group are very familiar with the blockchain, but blockchains and blockchain type people, I think, have very different incentives and motivations to institutions. The motivations of institutions are going to be the motivations they had 10, 20, 30 years ago. It's going to be about cost reduction. It's going to be about, and in fact, that actually pretty much is everything they do. The cost of compliance is very significant these days in TradFi. If you can find an alternative to that that is not going to introduce more compliance costs, then that's going to definitely be a winner for them.
Privacy is wanted in all elements of digital.
Hello. Okay. Amazing. Privacy is wanted and desired in all elements of interacting with the blockchain. I would say the very basic level is payments. Payments is probably the basis for a lot of transactions that we do on chain. So bank to bank payments, merchant to merchant, peer to peer, all of these payments being private is incredibly valuable. And then I think building on top of that trading, right? Like we know that an institution doesn't want to share necessarily the transactions that they're doing, the trades that they're making, or the assets that they're holding. And so trading built on top of that is very high priority. And then I think third level on top of those two would be finance, right? Like decentralized finance, yield, where can I deposit my assets, where it's held privately, where the strategies that are being deployed are private, and then how can I get the rewards from that? And so I would say everything builds on top of each other, starting at payments and then going to any kind of trading and then going to any kind of DeFi.
So, what would you say is the most practical path for institutions that are thinking about approaching privacy now? Like, what would be your recommendations to get started?
I think that's got to be driven by incentives beside privacy. I think that's got to be driven by creating systems and infrastructure, sort of like for finance, that is better than what they have now. And then ensuring compliance through privacy is the way to do that. And I think we are starting to see, like I say, some of that pressure coming from, the rise of stable coins, the rise of alternative payment rails that are not, sort of like based on conventional payment rails, they're blockchain based, and they are starting to eat margin for these companies. And that, I think, will be a more powerful incentive to engage with that kind of tokenized like asset domain than it would be to say, well, blockchains give you access to a superior set of privacy tools, which I believe is true. I believe blockchains do make it easier to adopt next generation PETs compared to trying to fold that into Web 2. I think this was a point that was made earlier in one of the sessions. But I do think it's going to have to be driven more by utility, where privacy is there to back that up, than it is necessarily going to be driven by privacy alone.
To be on the blockchain with privacy. So I think it's first finding use cases that institutions actually want. Usually, again, some kind of settlement on chain, some kind of asset or supply on chain, and then getting privacy done on top of that.
Are there any underrated use cases that you don't think have been explored enough in institutions just yet?
I can take that question. I think in addition to payment rails and the trading venue, we should just aim higher because now all these companies, institutions, they're building their own crypto dApps, but in the future they won't just let their assets sitting there doing nothing, being idle. They would seek for additional yield opportunities on top of these idle assets. So I would say privacy on the smart contract level is an underrated and not yet explored much use case. And also because of like the technical difficulties for now, just as the previous panelist Wei has mentioned, we have already achieved self-sovereign privacy via Zcash Monero. But what we really need right now, in my opinion, is having this compliance layer and just aim high, also aim for like a privacy preserving way in terms of all kinds of on-chain interactions like lending, yield farming, etc.
Yeah, I think like I'll take it to a whole different side without like DeFi as a spot. I don't think it's something that people here in this room think it's underrated, but I think like voting, the simple thing is voting. If anyone was in Amin's Amin's panel, he referred to voting. It's such a simple thing, to do, such a needed thing to do, and yet it's not yet adopted by institutions.
I'm going to be really boring here and suggest something that's a little bit more in line with what TradFi institutions do. So if you look at settlement, there are rules about how much cash you have to have on hand to ensure that you actually can settle balances and you don't get into a state of deadlock where nobody actually has the liquid assets needed to actually ensure that transactions go through smoothly. And this is known as the corset that banks have to maintain around their liquid reserves. I have the feeling that if you could find a solution whereby you could exchange information about upcoming trades more readily privately, then you might be able to run, for example, a leaner corset. And that is a case where you actually have something that banks genuinely want to do, which is run leaner in terms of their corset, where the key challenge is privacy. I think that's like an underrated potential application here.
That's super interesting. And I think my last one is also something that institutions don't directly ask for, but I think is really valuable. And that's using privacy as a way to eliminate MEV. Like if I'm an institution and I'm coming to place a trade, I expect to know the price of that trade. And if that price could change last minute, I'm not placing that trade. And so it's not something an institution will explicitly come and ask you for, but it is something that privacy can be used for that I think institutions would really appreciate.
Super interesting. It'll be interesting to see what ultimately unfolds. You know, I think the last month, 2 months, as I mentioned before, a year, privacy has certainly seen a resurgence to some extent. And some of these questions that, you know, we talked about here are things that, you know, we're hearing at Phoenix, and I imagine with some of these other teams, you know, weekly, how to approach privacy, how to think about it, things that are really basic, and then things that get increasingly more complex. And I don't know if you guys have anything else to share, any other like hot takes, tidbits. But one thing that, you know, our teams have been working on is thinking about how to approach some of these fintechs, enterprises, institutions with some of these frameworks in mind. As the privacy conversation continues to hopefully explode, this will be ever more prevalent and important. And so with that, our teams are working on taking all these frameworks, taking all of these, you know, ideas and contextualizing it in a way that really makes sense for your average CEO, CTO, COO. Don't want to get too technical, but really want to understand the need for privacy at large. And so I guess with that, I'll direct you to this wonderful barcode, QR code, sorry, that features our institutional guide that will be out soon. So please stay tuned for more. And thank you. And thank you guys. Thank you.
Thank you.
Thank you.
Thank you all for coming. That concludes the sessions for Encryption Day. We appreciate you all staying to the end. If you all go outside, there should be some snacks, some cocktails, I think. So head out there, get something, talk, and yeah, thank you for coming.